exactly what today's session is all about. Hello everyone and welcome back to this Applied Data Science with Python session. In this course, we are not just learning Python as a programming language, we will be learning how to use it as a practical tool for data science, data analysis, real-time decision making, and in the earlier sessions, we explored the core building blocks of this journey. We started with Python, where we understood homogeneous arrays, n-dimensional structures, vectorization, broadcasting, array attributes, and why NumPy is faster than lists for numerical computation. Then we moved to Pandas, where we learned about series, data frame, labeled indexing, positional indexing, slicing, and different ways to create and access tabular data. We also discussed why data science matters in the first place. Data is everywhere, in business, healthcare, finance, smart devices, online platforms, and everyday activity. The real value comes from transforming raw data into useful insights, identifying patterns, and using those insights to make better decisions. In today's session, we will continue that journey with practical focus on data structures, indexing, data frame operations, and data visualization concepts. We will also see how Python libraries help us work with structured and unstructured data more efficiently. By the end of this video, you will have a clearer understanding of how Python supports data science workflows and why these concepts are essential for analysis, visualization, and model preparation. Also, if you're interested in boosting your career in business analysis, do not forget to check out our AI-powered business analyst course. So this course is perfect for professionals looking to enhance their skills with the latest tools like Power BI, Excel, SQL, all while gaining hands-on experience with real-world projects. So you will also learn how to leverage generative AI for smarter and faster decision-making. Our program is IIB A-BABAC V3 aligned and helps you prepare for certifications like CBAP and CCBA. You will also engage with 10+ industry projects, 40+ practical activities, and benefit from live online sessions led by experts. Plus, with Simplilearn's Job Assist, you will get the support that you need to land your next big role. Before we move ahead, here is a quick quiz question. Which Pandas feature is used for label-based indexing? Is it A, ILOC, or is it B, LOC, C, head, or is it D, describe? Comment your answers below.
All right. So today we will start with what data science is, the basics of data science, what all we need to cover. Practically, we will be starting working with the advanced libraries of Python, that is NumPy, where we concept on numerical Python. Then we move on to the Pandas library. Then we will move on to data visualization library, where we would be covering Matplotlib, Seaborn, as well as the Plotly library. Another important aspect of data science is that no data science is complete without the concepts of statistics and maths. Not very deep concepts of maths, but definitely some concepts of statistics as part of data science. Then we will move ahead and try to understand what probability distribution is, how they really help in analysis of the data. Move on to the advanced statistics part of it, which refers to inferential statistics, data wrangling, and feature engineering. These two are the last points of this particular course, where we would be practically working a lot of data science, how we clean it, refine it, and prepare it finally to be built, to be used into the model. So we would be practically covering and dealing with a lot of real-time data like data imputation, scaling, binning, and grouping operations. Yes, learner, are you all getting this point or not? Right? So these are the course components. So that is why, again, I am requesting you and suggesting you to go through your basic Python, because that would be required. And as already discussed by the LSM, that you already have your LMS, the Learning Management System, where you get your hands-on exercises to practice and gain knowledge, course and projects, as well as ebooks for reference. So now, again, the question comes that what is data? Yeah. Can you tell me what is data? What have you understood? Data science consists of the term data and science. So let's try to understand these two terms. That what does data separately mean and what does science separately mean? Collection of information is data. Is this correct? Another important question is that do you think that data only exists in today's era, or data has always existed for the human mankind? Next question is, do you think that data exists only for today or it always existed? How did it exist, Ishan? How did it exist? How did it exist? So you just think of ancient man. How did the ancient man, store data when it start communicating? Accounts and banking system. We still have accounts and banking system, Nigam. I'm talking about, you know, a, uh, you know, uh, data existing since the evolution of mankind. So when it was ancient man, where we never even had houses, we used to kill animals, cook on fire and everything. And then we started storing information, some kind of language was developed in terms of sign language, symbols, and everything was written on maybe on a bark or leaves or on stones, right? Right, we have always been storing the data or whatever is preferable to us, whatever we want to store. We've always been storing those in terms of walls or caves, on the carvings of cave. Do we see that? And as human civilization developed, right, the civilized houses, more, like we understand Harappa civilization, Indus Valley civilizations, right? We started living in houses with other things. So the data also started getting evolved, our education system getting evolved, and now we started writing on the paper, keeping all the accounts, your name, records, we started keeping into files, right? We've always kept that data in terms of files. Yes or no? Right? And after the evolution of computers, that's around, the 1980s and 90s, that the data started getting stored in terms of our computer system. And of course, with the evolution of internet, the whole world now converges. So since it has been 60s, 7, 8 decades to this whole revolution, so we only understand digital data, right? Today, the data that we talk about analysis of the data or the science related to it, that data we understand it is in digital, in form of digits, stored in terms of memory. That is why you see a big, noise now about battery systems, semiconductor devices, because these are the lifelines. If this hardware is not there, then the data also does not make sense. You might have heard about this in the AI summit, that people are talking about data centers and the energy and the power to store that data, right? That is why there is this big buzz, because now data is the new oil of the whole world. Yes, do you all agree? Whoever has power to the data, whether it's China, America, everybody wants to be a big player. That is where that country, or that will be the ruler of the whole world. That will have the whole power. Right or wrong? Are you all getting this point? Right? Since you have been born in this, right? So you only understand digital data. That is why it was important for me to make you understand. It has always been part of our civilization, right? But today we are living in the world of digital data, whether it's in mobile phones, whether it's internet. I mean, without internet, there is no lifeline. We cannot even breathe without our mobile phone. Any payment that we want to do, anything that we want to study, anything that we want to do, without mobile phone, we are helpless. Agreed? Do you all agree? So when we talk about data, data is nothing but facts and figures, observations, measurements that we take. And now we want to do analysis on this data. Why do we want to do analysis of this data now? Right? The numbers, the facts, measurements. Tell me. Why? Why do we want to do the analysis of this data? Quickly, why is there so much of buzz around this data? To fetch meaningful information from raw data. So why do we want this meaningful information, Webhav? What do we want to do with this meaningful information? Come on, come on, 100 plus. Come on, NMIT. Come on, give me some answers, quick answers. MAE. Okay, make decisions. Okay. So it helps us to take decisions, right? the company take good decisions, right? Whether we should invest in that particular product or not, we should invest for that advertisement or not. And that's it. So the whole world is running on the profit, right? Sachin says basically to recognize patterns. So what do we do by recognizing patterns? Agree. We recognize patterns. So what do we do by recognizing patterns in the data? Tell me. Like to maybe report about your medical. Now do we see AI? And now let me ask you a very basic question. I'm not getting response from you all. Let me be very, very clear with you. Do you see AI and data science around you? Some practical applications? Yes, to build the model and to automate tasks. That's the new thing that AI has been doing, Darshan. Absolutely correct. But the question is, why do we want to do it, Darshan? So patterns helps to visualize easily instead of okay, they help to. But why do we want to patterns? Why do we want to analyze it? Why do we want it to automate tasks? What is the usage that we see around us? Do we see some AI data science application running around us? Do we see that? Yes, we see so much. Come on, tell me. What have you observed to ease our lives in terms of what? Give me an application. Come on. Nobody is able to give me an application where this data science AI is getting used. Come on. It's part and parcel of everybody's life now. No practical application, creating PPT in minutes. Absolutely correct. So we have tools which create PPTs in split of a seconds. Absolutely correct, Darshan. Good. Very good. What about others? Nobody else is using AI data science. Pattern analysis helps us to find out where exactly we are lacking, in where, which lacking certain. It's a very, very general statement. I want a particular application related to that. It would be better to if you can answer from that level. Build apps with AI agents. Okay, maybe in terms of sales. So give me an example that how it will help me in my sales to understand the pattern. Yes, it does that. It does that. Absolutely correct. What about others? We don't see so many applications around us. Don't we see recommender systems around us? Don't we see in healthcare systems, in pharmacy, in agriculture, when we move on to, booking up of our airline tickets, or even if, we are traveling with the Google map, do we see some intelligence, some data science happening? Automated mails, traveling apps. How is the traveling apps helping you, Manohar Reddy? Good, good, good answers. So, what is science? What does the term science mean? Recommendations is online platform. Yes. So what? AI and data science is a part of it, right, Ishan? So what? So what? Now I want everybody to tell me what does the term science mean? Science means that something that we are observing, and based on certain facts, observations, facts, we are going to trying to conclude, some conclusions, right? Study about something. It's not something, but something like, a plant requires, sunlight, or photosynthesis requires sunlight, air, and water. Then we perform certain experiments on it. And then we conclude that if I keep a plant in dark for 5, 7 days, it will, start drying up. So that concludes that plants definitely require sunlight for photosynthesis. And if I don't water plants, that is how it is going to be done. So we prove the observations through the experiments. Right, Sahana, Ishan, Nagendra, Hirshita, Pranav, right? Right? That point is getting clear. So, in this whole journey of data science, where we will try to analyze data and conclude, the analysis based on certain facts. It's not that, I am concluding something and it would be accepted. No, the conclusion about will be based on certain facts and proofs. Clear? Right? And if I technically talk about data, please learners concentrate here. If I technically talk about data, Data is divided into categorical and numerical data. When I say categorical data, what is your marital status? Are you married? Are you single? Are you divorced? Right? Are you widowed? So that's the marital status. What is the political party you are working on? Are you for the Democratic, Republican, Congress? Different political parties. What is the eye color? Do you have green eyes, blue eyes, black, brown? What kind of eyes? So different categorical data. And the other is discrete values. How many number of children are playing in the garden? Of course, they cannot be 2.5 or 3.76 children playing. So it has to be discrete value, 0, 1, 2, 3, 4. Defects per hour, basically the items which can be counted. And continuous can be any ranging from minus infinity to plus infinity. The weight can be 67.763 to 88.8123. Getting my point? Is this point getting clear to everybody, learners? Are you there? Right? Now, I'm going to give you one practical example where you will understand the use of data science completely. So, data science for business is also known as the DIKW model, where D stands for data, I stands for information, K stands for knowledge, and W stands for wisdom. Now, what does each term mean? Please try to understand. So data is nothing but raw facts and numbers. So for example, if I'm talking about sales of a car, right? So that is the data for a particular company. When I process that data, that becomes my information. For example, what has been the maximum and the minimum sales in the last 1 year? So maybe the dark blue points are referring to the maximum sales and the green one is referring to the minimum sales, or the months which has sales has happened. Getting my point? So again, I'm repeating, data is facts and raw facts and figures. Information is processed data. Now, knowledge means something which has been occurred over the years, not based on one particular data, but over. So now I have data for the past 5 years. I'm looking at the data for the past 5 years. And what do I observe? That maximum sales happen during in the month of my festivities, maybe during my Navratras or during the financial year of end. This is what my observation is. And minimum sales happens in the month of June and July. Clear? So this is the insight or the pattern that I have analyzed. And based on these insights, I will have a wisdom that definitely, now what we can do is that we can, now we can give our observation to the, sales team or the marketing team that, maybe we can have more offers during the Navratras or the festival times, Christmas times, right? So that our sales can have more increase or bumper offers so that it can actually impact our business. Getting my point? So are you now understanding how data will actually have the impact, or the, what you were saying were all of you were correct, but you were not able to relate the term. So how actual data really has impact on the business by understanding, analyzing the patterns, right? And this is known as the DIKW model. Clear? One more example, one more practical example from the New York Times story that, Hurricane Francis, we see these things happening around us. Hurricane Francis was on its way on the Florida Atlantic coast. So on Florida, there was a hurricane which was about to hit, the Florida. And it was Linda M. Dillman, Walmart's CIO, the Chief Information Officer. She thought that, one of the Hurricane Charlie had struck several weeks earlier, right? So what did she think? She thought that, Let's try to analyze the data where Hurricane Charley struck several weeks before and try to understand the history of the shoppers, right? Because we want a good impact on our sales, right? So what do you think? Now these trends are quite popular that a particular hurricane is about to hit. What would be the items that you would like to buy and keep it for yourself? Or like when you move to any Walmart or any kind of, smart bazaar or D-Mart, what would you like to buy from there? If I say, uh, some natural disaster is about to occur, how do you want to go about it? What all you want to buy? Tell me. Some kind of, remember the COVID times, what all everybody was buying. Everybody wants to buy basic groceries, fruits, vegetables, so that they have sufficient to eat, right? The water bottles, the medicines. Yes or no? Right? Right? So, there that could have been, and maybe, this is a little older times, story 2004. So maybe people would like to watch some kind of a movie CD which was more hit, and they would like to buy it, buy more of such things, right? Maybe a flashlight or even a power bank would work. Surprise everybody. The expert the data and found that the stores would indeed need certain products and not just the usual flashlights. And from the past, the top selling item was strawberry Pop Tarts, increase in sales like 7 times their normal sales rate ahead of the hurricane. So Miss Dillman confessed in an interview that the pre-hurricane top selling item was a beer. Getting my point? Are you now understanding the power of data and its analysis? It is impacting today's business. Yes, learners, are you understanding this point or not? So now moving ahead with the lesson number 2 in the LMS. So you all have your LMS, your LSM guided to you. Yes or no? Everybody has the material to access, learners. Yes or no? Right? So lesson number 2 is all about basics of data science. So what is data science? What have you understood? Data science is a multidisciplinary field that uses scientific methods, right? So we would be definitely using certain statistics, certain scientific research methods to conclude about our results, processes, algorithm systems to to derive meaningful insights and from structured as well as unstructured data. Do we understand the term structured and unstructured data? Structured data means something more related to in the form of table, Excel file, maybe, or SQL that you have done. Unstructured data is in terms of audios, videos, log files. Getting my point? So that is where this is the power of data science that will help us to give conclusion. So using a search engine or making purchase on Amazon provides valuable data to data science driven software system operating in the background. So, data science emerges from a combination of expertise, scientific methodologies, and technology. It's not only about data, but it is also about mathematical and statistics model that we would be covering up in this course, how we would be using it to analyze it, and different scientific tools and methods. So there are a lot of tools available, different libraries that are available, but in this particular course, we are trying to be using the Python language to do the analysis or, to find the conclusions from the data. Clear? Is this point getting clear to everybody? So one of the applications of data science in healthcare, which nobody was able to tell me, is that we all are using smartwatches. Is the smartwatch capable of analyzing my BP, the heart rate, right? What kind of stress I have, the number of counts I have done. Then it also advises you to go and take an activity, drink some water. It's been a long time. Do we see that, things happening through the smartwatch? Do we see that? Can I get a response from everybody? Yes or no? Something which is practically that we see around, which we are using. Kishan, Khushi, are we using it or not? Pragna, Purnesh, Pooja, Lokesh, Sachin, Sahana, Sahil, Shrikant, Siddharth, Shusti, Shreya, Shreya, Tanisha, are you all there? Gagan, Ishan? No? Learners, are you there or not in the session? Amrita, Diksha, Darshan, Dia. Yeah. So if we are wearing that smartwatch, right, and we transfer the data gets transferred to the different servers, and it is the enterprise server which analyzes the data and, tells me, what kind of activity I have been doing along my month, or maybe I have to focus more on my cardio, drinking more water so that I can take more informed decision if I am looking for a weight loss, if I want to have a better healthcare system, right? So we can analyze the data, our own data, how we are living, what kind of water, how much water are we drinking, how much steps we are walking. Based on that, certain decisions can be taken. Google also employs data science to offer relevant search recommendations as users as they type in their queries. So it gives the real time, the moment you're typing it, predicts the next word, that what do you want to search, that data science in health or in healthcare course or a healthcare research paper, etc. Similarly, finance domain, using data science can help a loan manager can easily access, whether you are, applicable for a loan or not. So once you have applied for the loan in the portal, like what all is important, right? What is your salary? How many dependents you have? Do you have a medical insurance or not? What are the different properties? Based on those kinds of analysis, what kind of, your CIBIL report is, credit report, approved amount, risk. Based on those criteria, decisions can be taken whether you will be approved for loan or not. Clear, learners? Are we understanding the applications of data science? Have we understood what data science is? So the data science process, what all is required? First thing, as I told you, is definition. Problem definition for different projects, for different domains, for different data. What are we looking at? What are we looking at? The loan application part of the person, or what are we looking at? The healthcare part of the person. So the problem needs to be defined. Based on the problem data, authentic data needs to be collected from the correct resources, right? If you want to know how many people have got, negative side effects after the COVID vaccine, we have to collect that reliable, authentic data. Once the data is collected, data cleaning and exploration is required. Now, what are the issues in the data? Can anybody tell me? Since you've done SQL, what are the problems, that a data can face? Can anybody tell me? Come on, tell me. Technically, missing data, absolutely correct, Sahana. Inconsistencies in data, very good, Meera. The null values in data, right? Errors in data, duplicate value data, absolutely correct. So all that needs to be cleaned and explored before we send it for further analysis. What will happen if we are not cleaning this data? Sahana, if you're not removing the duplicates or null values, what will happen, Meera? Sahana, what will happen? Normalization is a little different. If you're not cleaning the data, what will happen, Darshan? Inaccurate results, right? So that is a very, very important step in data science. And once done, we then move on to the feature engineering part of it. What does feature engineering do? That if any kind of, especially categorical data needs to be converted into numerical data, scaling needs to be done, binning needs to be done, removing of the outliers. So this is still here, we are going to complete our data science journey, right? This course, deals till this particular part of the whole data science process, right? In the next step, as you will move forward in machine learning, model building and training will be covered, or the deep learning models training will be covered. Finally, we can move ahead with model evaluation and the model deployment. Getting my point? Is this point getting clear to everybody? Right? So, the first step in the data science process is clearly define the goal or the question to be addressed through the data analysis. Gather the relevant data set information from different sources, pre-process, handling missing values, outliers. Then we need to transform the new features to enhance the data sets information, model building and training, and finally, model evaluation and deployment also needs to be done. Clear? And here in this particular course, we are going to understand data science from the Python perspective. And can anybody tell me why is Python a hit language? Anybody who can tell me why Python is a hit language in today's world? Come on, we've already done that. Why is Python a hit language in today's world? Is it easy to understand? It's a high level language, it's interpreted language, huge collection and libraries for data science and machine learning. Very good. Very good, Abhijita. Very good, Sahana. What about others? And as we have seen, it has multiple open source packages that we are going to study. That is the NumPy, the Pandas for data cleaning, exploration, as well as visualization. Clear? And one more feature which makes Python a big hit in the market. I discussed it in the beginning. You all forget that feature. It supports functional programming. Please always remember this point. And what is functional programming, Ishan? Good, good, Ishan. What is functional programming? What is functional programming? Functions can be treated as objects, right? They can be passed as parameters to the functions also. Yeah, so we all are clear. None of you are answering. Most of you, rather, I would say, are not answering. So try to understand the advantages of Python for data science, that it is an open source, it's an interpreted high level language that supports object oriented programming, ease of use and simple syntax, scalability when compared to R, availability of the wide variety of data science libraries and packages, compatibility with all major operating systems, creation of new data science libraries daily by vast number of online user communities, and powerful visualization libraries are there, right? And the different Python packages for data science that we would be covering in this particular courses First, we will concentrate on the NumPy library, which is used for scientific computing that supports large multi-dimensional arrays, matrices, and includes comprehensive mathematical library. Second is we are going to cover Pandas, which is efficient storage and manipulation of structured data, such as the time series and tables. SciPy. SciPy is an open source library built on top of NumPy and is used for scientific formula that also we would be covering up in this particular course. Stats model also we are going to cover is a Python module that provides classes and functions for estimating many different statistical models conducting statistical exploration. And Scikit-learn. Scikit-learn, we will cover a little bit part of it, not much because it's part mostly used for machine learning. So Scikit is widely used for open source machine learning library for Python, known for its simplicity, ease of use, versatility in handling various machine learning tasks. It identifies objects and images for autonomous vehicles and facial recognition systems. It detects fraudulent transactions in banking and e-commerce platform. It analyzes customer reviews for sentiment classification in marketing and social media analysis. Clear, learners? Are you there with me? And if I talk about Matplotlib, Matplotlib is a library. It is a comprehensive tool for building static, animated, and interactive visualization. We would be covering up Matplotlib in detail as we move along this journey to build different scatter plots, bar charts, histograms, pie charts. Advanced library over Matplotlib, Seaborn is another data visualization library in Python that is built on top of Matplotlib. It provides a high-level interface for creative, attractive, and informative statistical graphics like histograms, box plot, violin plots, etc. Then we would be covering up Plotly, which is used for creating interactive publication, quality graphs, and visualization. It is suitable for web applications also. Clear? So now let's do a quick recap of the different plots that you might know before. For example, let's first understand the line plot. Yes, learners, what is the use of line plots? I'm sure you must have all done it in your school days, in your mathematics, in your graphs, maybe science, physics, or math statistics. So can anybody tell me what is the use of line plot? Yes, learners, where do you use it? Do we see around these graphs now? Come on, Sahana, Ishan, Nagendra. Answer. Yeah. Do we see line plots around us? Of course, they are straight lines which show relationship either over two quantities comparing growth. So this is like x-axis. This is my y-axis. What kind of growth? Good, Fez. What kind of growth for x and y-axis? Especially if you are dealing with stock markets or anything which has been over a period of time, the sales of car over a period of time, or the sales for any monthly sales of fruits or vegetables in terms of economy. Very good, Fairs. Very good. Excellent. Anything else? Do we see now graphs on the temperature also? Something like temperature also. What will be the temperature in the next 10 days, monthly basis? Do we see that, Fairs, in weather applications? That's also very common. Do we do that also? We are always worried about what's going to be the temperature tomorrow. It's going to be really hot, cold, rainy. Do we see that around us or not practically? Come on, learners. Do we see that or not? Are you not using weather apps for things? Yes, come on, tell me. Tell me, learners. No. Nobody wants to answer. Nobody is using it. Sahana. So a line plot displays data points connected by straight lines, often used to visualize trends or relationship between two variables over time and other continuous intervals. Agreed, learners? Then a little, appearance, making the line plots better using the marker plots. What is this marker plot? It displays the data points with markers useful for scatter plots for visualizing individual data. If I really want to find out the relationship at this particular point, do we also try to draw the graphs like of your marks? Do we do that also? So Faz has changed his name to Trump. That's interesting. That's interesting. Faculties, your students are changing their names. So Faz has changed his name to Trump. Okay. Okay, that's interesting. Come on. So a marker plot is something which can use to highlight certain points. Maybe even it could be the marks or a particular specific condition and in the graph. Then scatter plots. Where do you see the scatter plots? Which gives the relationship between two numerical values. Come on, learners. In healthcare data, maybe the BP and the weight. People who are more with the weightage have more BP issues, or two numerical values can be used to compare using the scatter plots, right? Height and weight in a particular population. Then, have you seen some graphs like this, such as area plots, which help us to give the cumulative data? If this is the sales of the company, maybe the blue one is giving the sales for the first quarter. This is for the second quarter. This is for the third quarter. So an area plot visualizes the cumulative data changes over time, such as tracking the total sales, revenue over successive quarters. So where we tried, or maybe, if I want to analyze or give you a report card, so what was your result semester wise? What was your result in your first semester, second semester, third semester? Cumulative results can be easily represented using the area plots. Bar plots, do we see bar plots? I think so. That's very, very common that we see around us. Do we see bar plots, learners? Nothing but rectangular graph that show vertical and horizontal data based on another axis. Which gives the comparisons of the sales of different products over the month. It could be different, we see it as, students as display student grades in different subjects. Grid plots that you might have been using in your science or statistics classes to see the downfall or rise and other things, to mark certain particular points. Yeah. So grid plots basically help in comparison of multiple plots by enhancing the visualization points. Another very, very important graph is a histogram. Anybody who's aware about histogram? Yes, learners, can you tell me what is the use of histograms? This is the graph which we are going to do a lot. Very, very important graph in terms of data science. Let me tell you. Histograms in which we divide the data into different class intervals and then draw the, different values coming in that particular interval. So we say that histogram displays the distribution of data by dividing the values into bars and representing the frequency of each bin with the bars. Right? So histogram visualize the distribution of numerical data like income levels or exam scores. They help make inferences about data characteristic, underlying patterns, guiding decision making process, etc. Yeah, last but not the least, one of the favorite graphs which we all have dealt with is a pie chart, where the whole data is considered as 100% and a part of it, or fraction, is shown in different parts. Clear? right? It could be the share of languages in in the whole 100% area, or the different expenditure of the house in different areas that can be taken. So pie plots show the proportions of the whole, like the market shares or the survey responses, right? Nothing to worry. We will be dealing up with all these charts in detail when we take up data visualization. Clear? Right? So, a quick recap of what we have done. Data science involves analysis and interpretation of data to generate actionable insights. NumPy is an open source library predominantly used when working with arrays. Seaborn is a data visualization library in Python that is built on top of Matplotlib. And Python is a preferred programming language for data science projects across the industry. List one. And what is this concept known as? Can anybody tell me? Concept known as? Yes, Vaibhav. This is known as list comprehension. Is there any other way we can achieve this without list comprehension? A quick code without, can I achieve multiplying it by 3 without using this list comprehension? Quickly, can I get an answer? Yes, learners. Without list comprehension, can I get a quick answer without using this concept? I have to create an empty set and explicitly run a for loop. Anybody who can give me that solution quickly? Yes or no? Quickly. Explicitly we can. Who's going to give me? I want an explicit solution. Quickly. I'm waiting for the result. I'm explicitly waiting for the result. How can we do it explicitly? Come on, others. Gan, Ishan, can you give me the result? Good, Abhijita. Good. So let me quickly do this. Abhijita, I don't need to give this list. I'm going to keep this thing. I don't even want to give m is equal to 3. Do I need to give the range as length? Do I need to give it as range as length, Abhijita? No. Let me copy your code first. Let me copy your code. No, not really. Your code is little wrong in that sense. It's giving me 30, 60, 90, and 120. But if we look at this, I don't require these two things, right? You kept it as variable, but why range? Why range you want to do it? Okay, you're keeping it as list of I, whatever is the value at 0, 1, 2, 3. Okay, clear. Okay, fine. Let me put it as 3, and this is my answer. So, all right. So now when we did this example, what was the flaw that you saw? In the list and tuple or dictionary, especially the list, which is a mutable data type, what was the flaw that you found out? That when I want to perform a mathematical operation, that when I want to multiply the elements of the list with a numerical value, I have to, imply the for loop, right? Without that, it is not capable of multiplying each of the elements. Do you see that flaw? Yes or no in the list? Yes or no? Asha, Anusha, Abhirat, Shanmukh, Yadav, Podar. So that is why the NumPy library, advanced library, was being introduced. NumPy is a numerical Python library for computation of on homogeneous, and this is the power that this library has which helps us to create arrays. Arrays not in one-dimensional, two-dimensional, but in n-dimensional to store the data. So let me quickly give you what this particular package looks like, or library rather, looks like. Since NumPy is an open source material, let me share it with you. Yeah, do you see this? Everybody, please open this package which is available online, right? This is the, the NumPy 2.4.0 release. It helps us to create n-dimensional array, computing tools, open source library, which helps us. This is the material where you can, practically use it. It helps us in, working in scientific domains, array libraries in data science. It helps to extract, transform and load the data, exploratory analysis, model and evaluate, report and dashboard. All these things can be done with the help of machine learning, visualization, scientific domains, array libraries, etc. Clear? Lot of practical use, all the TensorFlow, all the deep learning activities, unstructured data is all stored in terms of n-dimensional array. Clear? Are we all getting this? Yes, learners. Yes or no? So what is the use of NumPy? NumPy is nothing but a numeric Python. It is a package used for computation on homogeneous and n-dimensional arrays, right? What are the properties of array? They are mutable. What does the term mutable mean? We can, and which is the other data structure which are mutable? Other data structures in Python which are mutable? List, dictionary, and which is immutable? Which are the data structures which are immutable? Tuples are immutable, strings are immutable, int, float, all are immutable. Right, very good. Good. What does the term homogeneous mean? What does the term homogeneous mean? When I say the term homogeneous, yeah, they all are of same data type. Secondly, it can be accessed using integer position, right? Integer position. Strings are accessed using integer position. Lists are accessed. That is, in other words, indexing is allowed. What are the two types of indexing available in Python? What are the two types of indexing available in Python? Very good. Positive and negative. Arrays deal with numeric data and high performance in calculation, right? So, what is the advantage of arrays over the list, right? We just now saw that in list, basically, we store pointer to the data location. So every data is stored in a different location. Therefore, accessing the elements of the list are different. And when I talk about arrays, they are stored in contiguous memory location. First of all, they are of homogeneous data type. Int will store some bytes of information. Float will store some bytes of information. So they all are stored in contiguous memory location. That is why arrays are faster than lists. That's why this data structure was created, because it is much more faster than the list. Clear? Is this point getting clear to everybody? And now let's understand the code, and then you will start writing the code. I want everybody to open their Jupyter Labs and start writing this particular code. I will ask anybody to show the file. I randomly ask anybody to share your screen. I want everybody to start typing and writing this code. And let's understand this code side by side. Learners, please start typing this code on the lab, Jupyter Lab that you have. The first and the foremost thing that is required for this particular course is import the NumPy as NP, that we import the library. The first step whenever we need to create, arrays is because it's not part of the basic Python, we will always need to import NumPy as NP. I want everybody to type in the code. I want faculties, please look at the learners, students, are they doing it in the lab or not, this particular assignment or not. And this is how we create the array. np.array is the name of the function, and these are the elements to be created in the array, that is 0, 1, 2, 3. Yeah, so when I print A, this is the output I have get. And when I do a type A, it seems like a list, but it is not a list because it's an object of class numpy.nd array. So by doing type A, I get the output as type numpy.nd array. Now, a.endem, these are nothing but the attributes of the array. A.endem gives me the dimension of the array. This is a one-dimensional array. The shape, the number of elements or the number of rows, basically it's a column vector. It is written like this, it gets stored like this, 0, 1, 2, 3. So the number of rows over here is 4, and length gives me the number of elements in the array. Everybody got this? Again, I'll repeat. First, we need to import the library whenever we have to create arrays. Once you have loaded the file, then you will load it. Not every time you write the code. Then, by using the np.array function, you are able to create arrays. Print the array. Give the type A, that is class numpy.nd array. A.endem gives me the dimension of the array. A.shape gives me the number of elements, and length.a gives me the length of the array. Clear? Shape always gives me the rows and column. Clear? Everybody has done it? Anybody who's facing any doubt? Any questions on that? Come on, tell me. Dhanush, Manohar Reddy, Chetan Kumar, Kirtana, Bhumika, Faiz. How many times Faiz has joined? Oh, so Malika Arjun is here. I was looking for you. Yes, Malika Arjun, are you able to run the code? Rishita, Karan, Kishan, Kohli, Khushi, Palak Pandit, Mokshita, Raksham, Meghna, Shifa Anjum, Saswat, Sahil, Shreya, Shashank Pai. So many Sri Rags are there. Vaibhav, Varsha GB, Bal Vivek, Harsh Praneet, Chaitra, Bhavishya Chandra, are you all there? Have you been able to do it? Good. Now do the next activity. Now do the next activity. Well, if you have imported this one, you don't need to write this code again. Now we had the range function in Python. Similarly, in arrays, we have a range function. And what exactly the range function? It will create or have data from 0 to 39. Please type in this. Like we had the range function in basic Python, similarly, we have the arange function over here to create the data. Clear, learners? Are you there? Now, by using the shape, can I change the 40 elements into a two-dimensional array? That is a matrix. That is, it. Now this array consists of 5 rows and 8 columns. Do you see the output? Are you able to run the code? Give me a quick thumbs up who's able to get the output. Good, Abhijita. Good, good. Others only two out of 100 plus batch. Now you're 120 plus, and not even 20 of you respond in this batch. Is it possible to change this to 8 comma 5? Is it possible to change it to 8 comma 5? Is it working? Give me a yes or a no. Is this 8 comma 5 working? Very good. Can I change it to 4 comma 10 also? Can I change it to 4 comma 10? That means the multiplication factor is again 40. But can I change it to 4 comma 4? Run it and then tell me. Run it and then tell me, Manohar Reddy. Akash, run it and then tell me. No. Can I change it to 2 comma 4 comma 5? Can I change it to 2 comma 4 comma 5? Let me rub all this. Can I change it to 2 comma 4 comma? Why? Why, Ishan? Why, Naina? Why, Abhijita? Tell me. Why? Why can I change it to 2 comma 4 comma 5? Overall, the factors of the multiplication is 40. 2 into 4 is 8, 8 into 5 is 40. So can I change the dimensions of the array? Good, Akash. Can I change the dimensions of the array? Can I change? So what do I mean by dimension? Everybody is done with the activity? Yes. So now please look here. What do we mean by dimensions of array? A one-dimensional array, right, will only have one dimension, that is axis equal to 0, and the shape is only having 4 elements, or you can say it in terms of 4 columns, right? So the shape, the axis and the dimensions are very strongly related with each other. A one-dimensional array will only have one axis, and the shape will also give about one dimension. And a one-dimensional array is known as a vector quantity. Please be clear with this concept. A one-dimensional array is known as a vector quantity. Now, when I talk about two-dimensional array, it consists of rows and column, and a two-dimensional array is always known as a matrix, right? Agreed, learners? And of course, it's a matrix. So it consists of two axes. Axis 0 refers to the rows. Axis 1 refers to the column. So the shape is 2, comma 3. I hope I'm going very, very slow with you all, giving you all the, examples, making you to do the practice on the lab. Still, anybody having any difficulty? Please let me know. Yeah, are we clear with 1 and 2 dimensional? Now, when we look at 3 dimensional array, it will obviously consist of 3 axes, axis 1, axis 0, axis 1, and axis 2. Axis 0 refers to it. You can consider this as a slice of bread. So each slice, so this particular array consists of 4 slices. In each slice, we have 3 rows and 2 columns. Clear? And the 3 dimensional and above are all known as n-dimensional array. Clear? Any questions, any doubt till here, learners? Yes, Stanley, Bal Vivek, Harsh, Bhavishya Chandra, Vivek, Vinaya. Any questions, any doubt? Varsha, Vaibhav, Jagannath Pati, Sameer, Sahil, Suhana, Shrikant, Shrishti, Siddharth. Yeah. So let's do a lot more practice on this. Yeah. So I want, have you been able, has everybody downloaded the material? Has everybody downloaded the material? I want everybody to open 3.01. I'm sending it through the chat also. I want everybody to open this 3.01 in your Jupyter lab or whatever tool you are using. Anybody who's facing difficulty to work on the lab? I was there with the lab and I've already opened 3.01. So I'll be opening it in Colab, in Anaconda because it's more clear. So anybody who's facing difficulty, please let me know. You can share your screen. I can help you out with that. Excuse me. Excuse me. Are you ready with the file? Can I get a quick thumbs up, quick thumbs down? Shreyan, Shrikant, Sruchti, Siddharth, Harshita, Nagendra, Bhumika, Harsha. Can I get a thumbs up, thumbs down? Good, Nigam, you're ready. Ashish, you're ready. Great. Neha is also ready. Bhumika is also ready. What about others? Good, Aishwarya. Good, Vaibhav. Anybody who's getting an error when one is running the uh, importing the NumPy file? Anybody who's getting an error? Good, Ganga. Good, KM. What about you, Faiz? Tell me quickly. Anybody who's getting an error? So what is NumPy? Now, if I ask you, see over here, I've already given you the link of the numpy.org, right? I've already shared this, open source link. Now, if I ask you the question, what is NumPy? Who's going to answer this? Come on, learners, respond. Yes, what have you understood? What is NumPy? Everybody answer. Come on, we've just done it. What about Shashank? Shashank Pai, why are you not answering? Shifa, Sahil, come on. Prajwal Teli, answer. Prakhyat, Pranav, Purnesh. Sahana says open source library for mathematical operations. Okay. But it's not a complete answer, Suhana. Used for computational and what multidimensional? What multidimensional, Abhijita? It's again incomplete. So give me a good complete answer, Suhana, not break it. Give me a complete answer. Who's going to give me a complete answer? What is the use or what is NumPy library? Give me a complete answer, Abhijita, Suhana. Others can also respond. Bhumika, Monica, Meera, answer. Munukulu Akash, Nagendra P, Naina Ramesh. Come on, answer. No, you don't want to respond? Khushi V, Kiran, Kishan, Lakshmi Shrikar Reddy. No, you don't want, nobody wants to answer. Nobody understands what is. What is the use of NumPy? No? Varsha? So NumPy is a library which helps us to create, yes, it helps us to create arrays which help in faster mathematical numerical operations. Very good. Right. So what are the properties of these arrays? Tell me three properties of these arrays. What are the three properties? I gave you a lot of things. So anybody who remembers the three properties of arrays? They are mutable. Very good, Hamsika. First is mutable. Second, homogeneous. Excellent. And the third one, can be accessed via indexing. Good. Excellent. Only Hamsika was there. Fixed size. Not fixed size. It's mutable, Suhana. It's not fixed size. It's mutable. Easy access in what terms? We can say faster mathematical operation, Suhana. No, both answers are wrong, Suhana. Got it? Homogeneous, mutable, can be accessed via indexing, faster mathematical operations. These are the properties of arrays. Clear? Jayant Yadav, are you there in the session? Why are you not responding? Parnika, what about you? Okay. So what is the object called when arrays are created in NumPy library? What are the object? What is the name of the object? NumPy creates array objects known as, what are they known as? Arrays create objects in NumPy which are known as n-dimensional objects. No, they are not heap objects. Wrong. Wrong, Akash. They are known as ND arrays. Clear? Right? So what are the advantages? They are faster than the traditional Python list. We will just now see how it is faster. It provides supporting functions. Arrays are frequently used in data science and they are stored in continuous memory unlike the list. Did we understand this point? Lists are stored in different memory location. Which is the Python function which is used to create arrays? Is the Python function which is used to create the NumPy ND array object. It's the np.array function. Good, Manohar. Good. Yeah. Learners, are you there with me with this code? Everybody has this code. I'm just making a few changes over here. So now do you see the first step in creating this thing is importing the NumPy library. Then I have created this array using np.array. Here my array gets printed. The type is that it belongs to the n-dimensional array object type. Please remember this point. Even a one-dimensional array is an object of ND array. Dimension over here is 1. Shape, the number of element is 3. The length is 3 and the data type is integer data type. Now, what do we mean by homogeneous data type? Moment I add floating value. Please look here, learners. Moment I add a floating value, all my values become floating automatically and it gives me the data type as float. Clear? Are you all getting this point? Why these arrays are said to be homogeneous? So when I create this np.array simply learn, it's a string. It's a array of string data type. Yes or no? Learners, are you there with me? Let me put this over here. Learners, are you there with me? I'm making the changes over here. You can play around with it now to understand the concepts. So it gives me an error over here. So this is an array, Simplilearn, which gives me that it's a dimension. Dimension is 0, so the shape is also 0. Length, it's unable to give me the length of it. It's an unsized object, so we can remove that. And the data type is Unicode 11. So Unicode 11 refers to the string data type. Is this point getting clear to everybody? I want everybody to practice this code I'm sending on the chat also. Are you able to do it or not? Faiz, Hamsika, Harshita, Parnika, are you able to do it or not? Jayant Yadav, Jivita, Geetashri, Mahidar Reddy, Manohar Reddy, Danush, Darshan, Diksha, Nurag, Anusha, Anvita, Asba, Ayush, Aditya Yadav, Aishwarya. Good, Neha. Chetan, are you facing difficulty? What about you, Mallikarjun? Tejas, Sushmita. So here we have array 1 again. It's a one-dimensional array and the data type is of float. It will make all the other data type homogeneous. And even if, I make one of them as a string data type, okay, you see all of the data type becomes string data type. Have you understood this homogeneous property of arrays now? Let's create arrays of zero-dimensional arrays. So zero-dimensional arrays are known as scalar values. One value, that means any integer, float value, they are nothing but zero-dimensional arrays. They are scalar values. Do you see this? Array is a vector. Two-dimensional array is a matrix and a three-dimensional array is n-dimensional array. This is the code for zero-dimensional array. One value. You can give any values over here. That doesn't make only one particular value over here is allowed. Even if you put it as minus, maybe as negative, it will still run it. When I create one-dimensional array, The number of elements become my shape. So 4 elements are there in this vector. Matrix. Now look at matrix. One small hint or tip. The number of square brackets starting gives me the dimension of the array. So two square brackets. So it's a two-dimensional array. And look at the beauty of this particular library. Please look here. So this is my zero-dimensional array, one-dimensional. And see, it gives me my two-dimensional array as a matrix. And what is the shape? The number of rows is 2 and the column is 3. And what about three-dimensional array? Please look here. These are the 3 square brackets. So this is my three-dimensional brackets. So how many slices do I have? This is my first slice. This is my second slice. So the first dimension goes as 2. Each slice has 2 rows in it and 3 columns. So therefore, the shape of a three-dimensional array is 2, 2, 3. Again, I'm repeating. 2 is the number of matrices, different matrices in the three-dimensional array. Each matrix has 2 rows and 3 columns. Now let's understand arrays versus list. So which one is a better data structures, arrays or list? Yes, learners, tell me which one is a better data structure, arrays or list? Come on, nobody's there with me. No, nobody is able to answer this question. Again, I'm repeating it. Which one is a better data structures, arrays or list? Only Vaibhav says arrays. What about others? Why arrays? Tell me. Tell me, Nana. Why arrays? Hamsika, Vaibhav, Varsha. Tell me why arrays. It's mutable. Even lists are mutable. Nana, that's not the correct answer. Even lists are mutable. Even lists are mutable. Why, Vaibhav? Tell me. List is better, Varsha. Why? Why list is better, Varsha? Why list is better? Tell me, Vaibhav. Tell me. Now let's look at practically. Let's look at practically. Look here, learners. What are we doing over here? What is an underscore array? What is this? And how many elements am I creating? What is this? An underscore array. Tell me. By using the arange function, it will have elements from 0 to how many? If I look at over here, 99,99,999. Agreed? That means how many elements am I creating? 1 crore. 1, 2, 3, 4, 5, 6, 7. Yeah. Nobody talks less than crores now. So this is 1 crore elements I've created in this array. Agreed? Similarly, I've created in the list 1 crore elements. Agreed? Naina, Varsha, Vaibhav, Mika, Harshita, Hamsika, Gendra. Are you there or not? Okay. When I print an array, it gives me a beautiful answer, right? But when I try to print the list, it gives me that data rate exceeded. It doesn't give me the output. So why arrays? Because arrays are stored in homogeneous memory location. homogeneous, not homo, we will not call it as homogeneous, sorry. We will call it as contiguous, not continuous. The means the same, but contiguous memory location. Now clear? Everybody is getting this error? Or somebody is not getting this error or this warning rather. Now, what am I trying to do in this particular code? Look here, learners. What are we trying to do in this particular code? We're trying to calculate the time, the CPU time taken by, multiplying each element of the array with 2, but 10 times. So what answer am I getting? It takes 438 milliseconds. And the same thing, I want to do it with a list. Now look at over here, the beauty. I'm only using an asterisk symbol, but here I have to use explicitly for loop for multiplication. So which one is faster? Arrays or list? Which one is faster? Now tell me, Varsha, Vaibhav, Abhijita, Tuhana, tell me. Arrays are faster or lists are faster? Which one is taking more time? Or which one is taking lesser time? Which one is faster? Quickly. Right. Arrays are faster to do mathematical operations. So if I want to do mathematical operations on the data, that's why it's known as NumPy. Do you understand? Generally, we talk about numerical data. And to process or to do mathematical operations on this numerical data, arrays are faster. Now clear to everybody? The answer was not mutable. Got it, Nana? That's not the reason. But definitely, uh, arrays, NumPy arrays are faster than the list. All right. So we have this NumPy. What is NDRA? NDRA is the name of the object which array gets created. The different attributes of arrays are shape. What does the shape give you? The number of rows and column of the array as one dimension. What is a one-dimensional array known as? Yes, tell me. One-dimensional array is known as vector. A two-dimensional array is known as a matrix. Three-dimensional array is known as n-dimensional. Zero-dimensional array, known as a scalar value. Good. What does endim give you? What does the endim give you? What does the endim give you? The dimensions. So, and what does the D type give you? What does the D type give you? Yeah, the data type. And what does the item size give you? Good, Chetra. What does the item size give you? What does the item size give you? It gives you the number of bytes occupied by each element. And size gives you the number of elements. Clear? Please try to understand. If this is my array, right? This is the matrix with 3, 5, right? The shape is number of rows are 3. The columns are 5. The dimension is 2, right? The size, the number of elements in this matrix is 15. Data type, each data type is of int 32. What does int 32 mean? 32 mean, right? So int 32 means that the 32 bits of memory are required to store the integer data type. And item size always gives you in terms of byte. So 32 divided by 8, 1 byte is equal to 8 bits. So the answer is equal to 4. 4 bytes. Clear? Any questions, any doubt till here? Right? So now let's start working on 3.02 to open the next file. I want everybody to open the next file, that is attributes and functions. Anybody who's facing difficulty in opening attributes and functions? Are you all ready? Can I get a quick thumbs up? I will not be able to share this file, Vaibhav. I want everybody. Okay, let me share it with you. I want everybody to now work and be ready with the files tomorrow. Will you be able to do that? Today I'm sharing it, but tomorrow you have to be ready. Will you be able to do that? I'm sharing the whole folder with you all. Can I do that? I'm sharing the whole folder. Vaibhav, does that help? You should be ready with the file tomorrow. I want everybody to be ready with the file tomorrow. We've only started working on 3.01, 3.02. Tomorrow we will be covering up 3.02. We'll be doing a part of it. That's just the attribute. We will cover 3.02 tomorrow again with functions. Then we will move on to 3.03 with NumPy, arithmetic, statistical, and string functions, indexing and slicing of NumPy. Clear? After completing NumPy tomorrow, then we will move on to the Pandas data structure. Getting my point, learners? Is this point getting clear to everybody? Any questions, any doubt? Quick learners, tell me. Let's begin with 3.02. Are you ready now, Vaibhav? Bhumika? Lena? So what are the different attributes of NumPy array? Data, item size, the shape, the n dimensions, the dimensions, right? Array size and the data type. So now if we look at the first example, please look here, learners. If you look at the very first example, right, this is the library that we import. This is the array which I create. If you look at over here, there are two square brackets. So therefore, it gives me the dimension, right? It is a two-dimensional array. This is how beautifully my array gets printed in terms of matrix. And now I can see it has the shape 2, comma 3, that is 2 rows and 3 columns. The number of dimensions is 2. The size of the array, please look here. Array dot size gives me the number of elements. It is 6. The array stores .d type. Each data type is of integer 32. Size of one array element is 4 and array's data. What is the memory location at which the data is located? And if I make certain changes with a string or with a float value, we know that all the values will be considered as float. So the number of dimensions is 2. The shape is again same. Size is also same. But the size of the byte changes. So the size of one array element is 128. Clear? And if I talk about the explanation of attributes, what is ndim? Ndim gives me the number of axes of the array. So arrays, so the shape, as I told you, the dimension is related with each other. If a particular array has two axes, it has two dimension. Shape provides the size of the array for each dimension. The output data type is generally in the form of tuple. If it consists of 2 rows, 3 column, the output will be 2 comma 3. If it has 3 rows, 2 column, output will be 3 comma 2. The size gives me the total number of elements in the array. So 2 comma 3 will give me 6 elements. And if this array has how many rows? 1, 2, 3 rows and 4 columns. 3 into 4, 12 elements. Data types gives me the data type of each of the arrays. And item size shows the length of one array elements in terms of bytes. So y divided by 8, 1 byte is equal to 8 bits. So therefore we get the answer in bytes. And then it is an attribute offering access to the raw memory of the NumPy array. Clear? So a quick revision of NumPy that we had done yesterday. So NumPy, or the numeric Python, is a package for computation on homogeneous arrays. What do we mean by the term homogeneous? What do we mean by the term homogeneous, learners? That basically they contain data of the same type, n-dimensional array. So what is the biggest advantage of arrays you understood yesterday? We discussed that. What is the biggest advantage of arrays? They are faster than list, right? They're definitely much more faster than list. And why are they faster, if I ask you? Because the data is stored in contiguous memory location. Did I explain that point? Right, Weber? So what are the properties of the NumPy array? The properties of NumPy arrays are that they are mutable. That means they can be changed. Homogeneous, they are all of the same data type. Can be accessed using integer position. Arrays deal with numeric data. And it gives high performance in calculation. Clear? Are we clear with all these points, learners? And this is what we were talking about. List stores the pointer to the data location. That is why lists are slow as compared to arrays. Arrays, the data are stored in continuous memory location. Clear? Vaibhav, Ganga, Bhumika, Nagendra, Prajwal, Meera, right? And yesterday we had written codes to create arrays. So the first thing that's required is importing of the library, right? And then it is np.array function, which is used to create the array. What are the different attributes of an array? Can anybody tell me what are the different attributes? Ndim gives me the dimension of the array. Shape gives me the shape of the array, the number of rows and column of the arrays, right? And we also have a range function. Do we understand this a range function, which is exactly the same as the range function in Python, but the values lie between 0 to 39, and this is nothing but it refers to numbers of rows and column. Clear? Right? And as I told you, the dimension, shape, and axis are very closely related. One-dimensional array has axis 0. The shape will have only one parameter, that's the number of elements. What is one-dimensional array known as? What is one-dimensional array known as? Very good. That's known as a vector. Only Vaibhav understands in this session. Only Vaibhav understands. He is only going to respond, nobody else. Then we had two-dimensional array, right, which consists of rows and column. That is axis 0 refers to the number of rows. Axis 1 refers to the column. So what is the other name of arrays, two-dimensional array? Very good. That's also known as the matrix. Very good, Meera. Very good. And if I talk about n-dimensional or three-dimensional array, three-dimensional array will consist of axis 0, 1, and 2. Axis 0, you can consider it as the slices of the bread. Axis 1, the number of rows and column in that particular bread or array. Clear? So what are the different attributes of an array? Dot shape gives me the axis or the number of rows and column. End dot ndim gives me the dimension. Dot d type gives me the data type. 32 refers the number of bits required to store, number of bits. Item size gives me the number of item size required to store one element. So we do divided by 8 because 1 byte is equal to 8 bits. And dot size gives me again the number of elements. Clear? Is this point getting clear to everybody? So now today till now we were only revising what we had done yesterday. And now we begin with today's session. We have to understand functions. We'll continue. I request everybody to open the 3.02 file. Please go to your LMS, download the material and be ready with the material in your Jupyter Labs 3.02, 03, 04, 05. We are supposed to complete it today. I request everybody to go to your LMS, download the material and be ready with the files in your Jupyter Labs. Anybody who's facing any difficulty regarding the material or the lab, please let me know. Anybody who's facing difficulty regarding the material or lab, please let me know. Yes or no? Can I get a quick thumbs up? Are we ready to begin with today's learning? A quick thumbs up from everybody. Quick. Can I get a quick thumbs up? Are you all there in the session or not? Or are you sleeping? Parnika, Suhas, Malika Arjun, Rakesha, Rishita, are you there or not? Rakshita, Parvikshika, Pranav, Lokesh, Ranjan, are you all there or not? Okay. Now let's understand with few function. First is transpose function. So transpose function, as we understand from the perspective of matrices, that it interchanges the rows and column. Flatten will convert any array, any shape of array into one-dimensional array. It will convert it into one dimension, and reshape will change it into rows and column. Clear? So the NumPy transpose is nothing but if this particular array is of the shape 2 comma 3, why 2 comma 3? It consists of 2 rows and 3 column. And when I run this np.transpose function, it becomes into 3 comma 2. Clear? Is this point getting clear to everybody? When I talk about flatten, now the arrays of any shape, it's not that two-dimensional arrays, it's applicable to two-dimensional. Transpose is also not applicable to only to two-dimensional, but any n-dimensional array. Similarly, when I use the word flatten, any n-dimensional array can be changed, is always changed into one-dimensional array. Please be clear. So what can be the two ways in which flattening can happen? One is row major, that I take this as my first row, right? So the elements of the first row are placed first and then the elements of the next row and so on. But if it is column major, I have to change the order equal to F. So first the elements of my column get flattened and then the elements of the second column get flattened. Clear? Is this point getting clear to everybody? Is this point getting clear to everybody? Yes or no? Ishan, Bhumika, Neha, Nagendra? And when I talk about reshape, we can change it to any shape. A one-dimensional array can be reshaped to 2 comma 3, 3 comma 2, and even in more dimensions, 6 comma 2, 2 comma 6. But can I change this 3 comma 4 to 4 comma 4? Can I reshape this 3 comma 4 to 4 comma 4? No. Why? Because 4 into 4 is nothing but your elements are 16, which it will give me an error. Clear? Is this point getting clear to everybody? Now there is this activity. I want everybody to open their Jupyter Labs and start writing this first code. I want everybody to open their Jupyter Lab. Faculties, please take a note of this, that learners are practicing this particular code. I want everybody to first do this code. Copy code quickly. Let me see who does copy paste the code and gives it on to me on the chat. Let me see who is the smarter one in this particular session and batch. Yeah. So the first code says import the NumPy. We are creating an array A of one dimension. X, we are creating a copy. And here we are trying to change the value of one of the positions of the second array, like 0, 1, and 2. So I want to change this value of 3 to 99. So when I do it for A, it does get changed. But when I do it print X, the value does not get changed. Can anybody tell me the reason why? Value in X not getting changed? Because X over here, we are creating a new variable in memory. That means a new memory location is getting allocated. The memory location is not same as that of the A. It is different. Getting my point? Has anybody done the code and check the output? Writing these 4 lines. Yeah, paste the code on the chat, Vaibhav. Good, Nana. Good, very good. So did you see the change? Did you see the change? Yeah. Similarly, but when I create a view of the array, now run this code, quickly make the changes in this. Now, instead of copy, create a view, and now you will see that both the values are getting changed. It will give me an output change in B also, as well as X also. Getting my point? That means both BX and B are pointing to the same memory location. Everybody is able to view this? Everybody is able to do this particular activity or not? Only Vaibhav has given me a thumbs up. What about others? Is it that difficult? So now getting back to the file, I want everybody to be ready with 3.02. Are very clear with the functions of the NumPy. Good, Suhas. Are we clear with the attributes of the arrays? Let's start with the functions. Can I get a quick thumbs up? Thumbs up. Everybody is ready? Are you ready with this? Great. All right. Yes, learners, let's start with the first code. That import NumPy as NP. Array, np.array, and the dimension is one dimensional and it consists of 12 elements. So can I change these 12 elements into 12 comma 1? Can I reshape this? Are you there with me with the code? Yes, learners, do we see that? So now we see this one-dimensional array now changes to two-dimensional with the shape 12, comma 1. We can also reshape to 3, comma 4 because the total number of elements 3 into 4 is 12, 2 into 6 is 12. So we can reshape it. Can I reshape this particular array into 3 dimension? 3 comma 2 comma 2, is it allowed? Yes, learners, is this allowed? So reshape, we can change any dimension to any dimension from higher to lower and lower. Yes, can we change arrays from lower dimension to higher dimension and from higher dimension to lower dimension using reshape? Yes or no? Tell me. Reshape function can be used to change any dimensions to any. Yes or no? Of course, when the number of elements are the same. Can I change the dimension from 1 to 3 and then 3 to 1? Is it possible? Vaibhav, Bhumika, Meera, Prajwal. Yes, we can too. This is the power of reshape function. Only Vaibhav understands in this particular batch, nobody else. Anya, what about you? Mamata, Monica, Nagendra, why are you all not responding? Aishwarya, everybody is getting this code, or are you all facing difficulty? Please let me know. Can I change it to further dimensions such as 1, 2, 3, 4, 5? Can I change a three-dimensional array or a one-dimensional array to five-dimension array also? Is it possible? Yes, because 2 into 3 is 6, 6 into 2 is 12, 12 into 1 is 12, and 12 into 1 is again 12. So the total number of elements remain 12. That is why we get these whole of arrays. Clear? Is this point getting clear to everybody? All right. And we see that a reshape function -1 will automatically bring it back to one-dimensional array. So if you pass the parameter in reshape as -1, you will flatten it out to get it as one-dimensional array. But there is one more function which exists in NumPy array, that is flatten. It consists of these attributes. C means flatten array elements into row major C style. F means in column major style, as I told you. So it's either, row major style or a column major Fortran style. A and K are not used nowadays so much because A means to flatten array in a column major order if A run contiguous in memory or row major wise. So now we have, evolved from these issues. So, the two main orders or the, types of arrays that exist are C and F. Then we have K, which means to flatten array elements in order of the elements laid out in the memory. Clear? Is this point getting clear to everybody? All right. So now what is A? Can you tell me the dimensions of A? Quickly tell me. Who's going to tell me? What is the dimension of this array A? Highlighted array A. Yes, learners. What is the dimension of, it's a two-dimensional array. And when I do a flatten, right, normally by default, it will do it row wise. So it will take order is equal to C. Okay. And C is equal to A dot flatten, order is equal to F. So what is the difference? If this is my two-dimensional matrix, so if I do row major, it becomes 1, 2, 3, 4, and column major 1, 3, and 2, 4. Do you see the difference? Do you see the difference? Another important point that you have to understand over here is that B is the copy, not the view of array A. What is the difference between copy and view? What is the difference between copy and view? Yes, learners. None of you understand this? Again, I'm putting copy does not change the original array. It creates a new one, whereas view does. So if I make changes in my B, will it be affected on A? If I make elements in B, will it be affected in the original array? Yeah, it will not have that effect. Good, Darshan. Ishan, are you there? So any ND array dot flatten, it returns a copy of the array flattened into one-dimensional array. So that is the difference between reshape and flatten function. Are you getting this point? Flatten will always create a new array. It will return a copy of the array flattened into one-dimensional. So if we have this three-dimensional array and if we flatten it using order F, what is order F? Column wise, that is, I will take this first element 1 and 7, then 4 and then 10, then 2 and 8. Do you see the difference in three dimension? Then 5, 11, 3, 9, 6, 12. Clear? If I want to change the order, what will be the output? Let me put this. Show me for order C, normal one. Naz, are you doing it along with me? So it is like the normal order. And if I don't pass this parameter, will I get the same answer? Yes, I will get the same answer because by default, it takes row major wise. Do you all see this? The problem statement where it says as a data scientist, your task is to create a Python project that explores the NumPy arrays attributes and function. So this is the list given to you. Explore the key attributes, find out the endem, shape, size, and demonstrate the functions. Will you all be able to do this assignment? Will you all be able to do it? All right. All right. Okay. Now let's move ahead to the very important topic, that is how arrays or the NumPy library help in mathematical operations. So please try to understand. If you know NumPy, these are the two concepts that is you are expected to know, that the arithmetic calculations in NumPy are completely based on two main concepts. First is broadcasting. Second is vectorization. I want everybody to understand these 2 points because if you don't know these 2 points, that means you don't know what is NumPy if you're not able to answer this. For any arithmetic operations to be performed on arrays, both the arrays have to be of the same shape and size. Okay, so of the same shape, rather not size, but the same shape, making the arrays of the same shape. Then we also saw that vectorization is that using for loops for element by element operation, that when we wanted to multiply a particular term with in the list, we explicitly use the for loop. Yesterday, you remember, we had explicitly used the for loop. But in arrays, you don't need to define that explicit looping. It by default does the operation, thus making it again much more faster, right? Clear? Is this point getting clear to everybody? So what is the idea? That if suppose you have a list and I wanted to multiply the elements, so I had to explicitly use the for loop to multiply 2 with each of the elements, right, to get the answer. But when I am talking about arrays, first of all, the two arrays have to be of the same shape and size. That means broadcasting will happen. What is broadcasting? That it will make the two arrays of the same shape. Both will become vectors with 2 and 2. And by default, the implicit for loop runs to give you the output. Is the concept of broadcasting and vectorization getting clear to everybody? Neha, Vaibhav, Bhumika, Meera, Aishwarya. To understand the concept better, let's understand this with an example. Learners, please look here to understand this with an example. Let's suppose these are my arrays. Now, can you tell me the shape of this array? This two-dimensional array. Quickly, learners. What is the shape of this two-dimensional array? Yeah, this is 4, comma 3. Good. And what is the shape of the other one? That is also 4, comma 3. Are the two shapes same? Yes, they are. So can arithmetic operation happens? Yes, element by element. This element will get added with this. This element will get added with this. This element will get added with this to give you the output. Clear, learners? Right? So that means in these two arrays, no broadcasting is required. Only vectorization happens and the arithmetic calculation is performed. The first case is clear. Now look at the second case. What is the shape of this array? This is 4, comma 3. What is the shape of this array? Ganga, Meera, Vaibhav. It has consist of one row and how many columns? 3 columns. Very good, Vaibhav. Now, are my two columns matching? Are the two columns same? Yes, they are. And broadcast this one to the same number of rows now. So broadcasting is possible in this case. Therefore, it expands this array into 4 rows to perform the operation. Getting my point? Is this point getting clear to everybody? Yes or no? And of course, vectorization will happen. Good, Swayam. And of course, vectorization will happen for element by element calculation. Now look at the third example. What is the shape of the first array? It has consist of 4 rows and 1 column, and this is again 1 row and 3 column. Good, Chetra. Good, Bhumika. Now, how is broadcasting possible? You have to check that if one of the rows is 4 and other one is 1, right? So can we expand it to 4 rows? Yes, that's possible. And if this column is 3 and this is 1, can I expand it to 3 columns? Yes. So broadcasting can happen. It cannot, it is not necessary that the broadcasting happens every time. And it is not necessary that it will happen only for one array. It can also happen for both the arrays also. So here the both arrays again become of the same shape. Then the vectorization happens and then you get the very, very important concept. One more example. Please look here. I'm sorry for the marker which is being run over here. Yeah. Now, np.a range. What is the shape of this array? It is 1 row and 3 columns. Agreed. And arange function is giving the value 0, 1, 2. And when I do a plus 5, what is plus 5? It is a scalar value or a zero-dimensional array. Broadcasting will happen? Yes, it will broadcast it into 5, 5, 5, and then the vectorization operation happens. Clear? I'll again repeat it. Here in my first example, this is my one-dimensional array with the shape of 1, 3 values. This is my scalar value. So broadcasting will make both the shapes same as 1, 3, and then vectorization will happen output. Clear? Is this point getting clear to everybody? Now head to NP1's 3, 3. That's one of the other ways to create an array with all values 1. So the shape of this array is 3, 3. And this is np.arange3, 1, 3. Now, there should not be any confusion since the columns match and one of the dimension is 1. Can it be expanded? Yes. And therefore, broadcasting happens and then the vectorization operation. Clear, learners? Chetra, Bhumika, Vaibhav, Meera, Nagendra. Are you all getting this point? And again, in the third case, can both the arrays be broadcasted? Yes, when I have this shape of 3, 1, and this is 1, 3. Now, how come broadcasting is happening? Since one of the dimension is 1, we can broadcast the rows. The column is also 1, we can broadcast it into 3. So both the arrays become of the same shape and therefore the vectorization logic happens. Swayam, are you getting this? Is this point getting clear to everybody? Yes or no? But where broadcasting doesn't happen. Now suppose if this is the array of the shape 4, 3 and this is 1, 4. So now the columns are not matching. This is into 4, but since the columns are not matching, it will give me an error. Clear? Let's do it practically, learners. Are you ready with the file 3.02? Sorry, 3.03. Learners, are you ready with 3.03? Vaibhav, Bhumika, Neha, Prajwal, Meera, Swayam? Good, Ganga. Good, Bhumika. So do we understand now this particular code? Yesterday we had worked on this. That this is my list 1 and if I do an asterisk 2, that means this particular values are repeated. They don't get multiplied. Right? But if I want to multiply it, one of the way is by I create an empty list, I run the for loop and then each of the elements does it. But a beautiful way was solved by way above that we can also use list comprehension to get the output. Is this point getting clear to everybody? Are we clear with these points? Yes, learners. Okay. So now do you understand the beauty of arrays? Another beauty of arrays that by simply creating this array 2, 3, 4 and just by doing a multiplication 2, I get the values multiplied by 2. So what is the concept that is working behind this? Yes, learners, tell me. What is the concept? Working behind arithmetic operations. What are the two main concepts working behind arithmetic operations? First is broadcasting. Yes, that is 2 into 2 into 2. And then vectorization, that is element by element. Clear to everybody? Vectorization is now clear. All right. So different arithmetic operations are possible. One way is by using this plus operator, or you can also use the np.add function for addition. Minus is for subtraction, subtract. np.negative is a unitary method. You get all the values as negative. Then we have multiply, that is multiplication. np.divide, that is single division. Can anybody tell me what is the difference between divide and floor divide? Who's going to tell me this? Tell me, what is the difference between divide and floor divide? Yes, learners, tell me. Ah, come on, tell me. None of you can tell me the difference between divide and floor divide. That's basic Python I'm asking. Weber gives, large gives integer value. Are you sure? Floor division gives only the integer values for him. Divide gives the division value. Floor divide gives the remainder. No. Swayam is correct. It is the M% operator, the modular operator, which gives me the remainder. Gives me the quotient along with the the decimal values. This gives me the integer part of the quotient. Getting my point? Is this point getting clear to everyone? Mod gives me the remainder. Clear above? Please be clear. And double asterisk is used for finding a to the power b. Is this point getting clear to everybody? So now when I do A is my array, one-dimensional array or a vector, B is my scalar value. So what will happen? np.add. Is vectorization and broadcasting happening over here? Is broadcasting happening in case of this particular code? Tell me. In A and B vector, is broadcasting happening? No, Meera? Vaibhav says yes. What about others? One yes, one no. What about the others? Why no, Meera? Why Vaibhav yes? The 10 needs to be broadcasted to the same shape, right? Then only the vectorization will happen. Got my point, Meera? Yeah, so broadcasting is happening over here. So either you can use an np.add function or even a plus sign can work. Clear? Now tell me what is A and what is B? What is the shape of A and B? Tell me quickly. What is the shape of A and B? 2, 3, right. Why web of 2, 2? It's not 2, 2, it's 2, 3, right, web of. So is broadcasting happening over here? We are using subtraction. Is broadcasting happening over here? Is broadcasting happening in this example? No. Why Meera no? Why Neha no? Yeah, because they are of the same shape. But vectorization is happening. Very good, Neha. Very good, Meera. So, but vectorization is happening. Is vectorization happening? Is vectorization happening? Yes. Yes. Vectorization will always happen. What is vectorization? Implicit running of the for loop. Getting my point? Yeah. Similarly, we have A and B, both are of one-dimensional array. So either we can use np dot multiply A into B. So is broadcasting happening over here? In multiplication problem, is broadcasting happening over here? Yes, learners. Is broadcasting happening in multiplication problem or not? Come on, Neha, Meera, Vaibhav, answer. Bhumika, no, it is not, because again, they both are of the same shape. Yes or no? No for what, Neha? Are you understanding it or not? And vectorization will definitely happen. That element by element multiplication will happen. Clear? Is this point getting clear to everybody? Neha, yes or no? Vaibhav, Prajwal, Nagendra. If we talk about division, A is two-dimensional, B is one-dimensional. Is broadcasting happening over here? In division, is broadcasting happening? Yes, because they both will be made of the same shape. And that's how we get the output. And if I talk about power of A to the power B, so 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 34. 2 to the power 6 is this much. Clear? Getting my point? Ma'am, but how can we multiply 1 comma 3 matrix with 1 comma 3? See, it's not matrix multiplication element operation. So if this is A, B, C, D, this also has to be E, F, G, and H. It's not matrix multiplication. A will get multiplied by C, B will be getting multiplied by F, C will be getting multiplied by G, and D will get multiplied by H. It's not that matrix multiplication like this. It's element by element operation. That's why it is vectorization. Good, Nana. That was a very good question. Everybody is getting this point. Now, as I've been telling you, statistics is going to be a very, very important part of our whole data science. So, do we understand different statistical function? Do we understand the difference between mean and median? Can anybody tell me the difference between mean, median, and mode? First, tell me between mean and median. Yes, learners. Come on, tell me. What is the difference between mean and median? Anurag, come on, answer. Anvita, come on. Are you there in the session? So respond. Hamsika, what about you? Mahir Reddy, Geeta Shri, Parnika, Jivita, Kiran, Kishan, Kohli, Shrikar Reddy, Lekha. Come on, answer. Palak, Purnesh. What is the difference between mean and median? Tell me. Chetra, Varshini, Veenal, Vinaya, Bhavishya Chandra. None of you understand the difference between mean and median? Come on, come on. Tell me, tell me, tell me, tell me. Learners. Yes, mean is sum of all the values upon total number of value. Median is the middle value of the array. Do we understand STD? STD function in NumPy or Python is used to calculate the standard deviation of an array. That is how far are we away from the mean. Percentile returns the nth percentile of the elements in an array. And then min is equal to returns the minimum element of an array. Max is returns the maximum element of the array. Clear? Okay. So now over here are you all there with me with the code? So if I have created an array A with A range 11, that is value ranging from 0 to 10, then when I want to calculate the median, I will use np.median function. Mean is calculated through np.mean, and np.std gives me the standard deviation, and np.var gives me the variance of the function. Now np dot again, if it is, even if it is not a one-dimensional array, it's a two-dimensional array, we can easily find out the mean of all the values, the median of all the values, the standard deviation of all the values, as well as the variance. Clear? Are we understanding how NumPy library helps to calculate the mean, the median, the standard deviation, and variance of the data? The file that you are accessing is a little different. Meera, you want to copy all this code? The file that you are accessing is like this. I'll show you the file. Is it like this? Is it like this? Something like this? Since I have made, so here it is. So this function is there. Some of them are missing. Some would be the same, right? Okay, now let me work on this only. Yeah, so this one is there now. This is what you are talking about, learners. Now fine, let me use the same file. I'll not use mine. Let me use this. Yeah. Now are we clear? Better? This point is getting clear to everybody? Good. It means that you are working along with me. The ones who are able to answer and they are responding, that means they are working along with me. The rest are not. The rest are not. I don't know what are they doing in the lab. Yeah. Now, when I talk about percentile, np.percentile function is used to compute the nth percentile of the array elements. The nth percentile value should be in between 0 to 100. So when I want to calculate the 50th percentile or the middle value, it comes out to be 4. Yeah. The moment you feel there is any discrepancy, please let me know. So, do you have the assisted practice with you? Assisted practice or not? No, I don't see this assisted practice. Do you have the assisted practice or not? I don't see in mine. Okay. 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 Fine. Okay. Fine. Then perfectly fine. Now moving on to the string functions in NumPy. Some of the files have been. So now the string functions. What are the different operations that can be performed on the strings? When I do addition on string, what does addition on string mean? What does addition on the strings mean? Concatenation, right? Do you see this? And if I increase one of the values, you can do that. So, Mira, wherever you feel the code is missing, you can tell me, I can paste. We can wait and we can go slow, right? So it's something like this. So if we have two elements and if I increase one, so this is NMIT session. You see this? How it can concatenates the two elements at the same position. And if we, want to replace something, I want to replace this hello with a hi. I can use np.char replace function, which replaces this hello with an hi. Or if I just want to replace this capital H with also be there. So the hello H changed to yellow, H of Y also changes to whatever you want to call it. Wow. Clear? So I think so now you should get that confidence to play around with things, right? So try playing around with these, functions. Similarly, we can also work on converting the strings from lowercase to uppercase and from uppercase to the lowercase. Getting my point? Is this point getting clear to everybody? If we look at further thing down, you see this assisted practice? Arrays for arithmetic operations, for statistical operations and string of functions. Will you be able to do all these functions? This is the assisted practice that you have. Meera, Bhumika, Neha, Vaibhav, just confirm. Vaibhav says no. Why no? Please go to your LMS and download the material. Any one of you, please download the material and send it on the chat. My material does not have that, Vaibhav. You took it from my material. My material does not have it. That is why you're saying a no. Neha, Bhumika, can you do that for me? Meera, download, just send that folder, compressed folder of notebooks and other material on the chat so that everybody has access to it. I'm not sending mine because I have all the solutions. So I don't want to give you the solutions. Neha, Meera, Bhumika, will you do that? Please do that for me. Chaitra, Bhavishya, Vivek, are you there? Oh, good, Naina. That's good. Very good. Vaibhav, not yours. You have it from the LMS. Yeah, from the LMS. Yeah, good, good, Vaibhav. Good. Yeah, please check it out. Everybody work on assisted practice. Tomorrow we don't have a session. We will be meeting next week and I will first discuss and ask any one of you to share the screen. Okay. So the faculties who are there, please make sure that the learners have completed this assisted practice. Now move with the next concept, that is indexing and slicing. So what are the two types of indexing available in Python? What are the two types of indexing available in Python? Nobody understands this. Positive and negative. Very good, Vaibhav. Positive indexing always starts from 0 and negative indexing always starts from -1. Very good. Now, does arrays support that? Yes, arrays support both positive as well as negative indexing even at the same time. That was not possible in list or tuple, right? But in arrays, it is possible to use positive and negative indexing at the same time. So if this is my array with 1, 2, 3, 4, 5, 6 values, positive indexing always starts from 0 on the left hand side. We move to the end. So when I say a to the power 2, what will be the value? What is the value at index number 2? What is the value at index number 2? Come on, learners, tell me. For this index, for this array, it is 3. Only Tejas got it. And if I change the value to -2, what is the value at -2? It is 5, right? Both indexing are possible. Similarly, if I have a matrix or a two-dimensional array, this is nothing but my row. This is nothing but my column. So this is 0, this is 1, this is 2, and this is again 0, this is 1, and this is 2. Right? So how do I take the position? This is my first row and second column. This is my 0th row and 0th column. Can I do a mixture of positive and negative indexing? Yes, that's also possible. That this is my second row. Row will always come before. Please, we cannot interchange that. Row will always, any term written before the comma will always represent the row. And any term written after the comma will represent the column. So, and this is how we get this element as 9. Clear? Is this point getting clear to everybody? Same, simple, right? So two-dimensional array, we have two axes. The first axis always represents the row, which is also known as axis equal to 0, right? And this represents as axis equal to 1, that is the columns. Okay. Now let's see who's able to answer this question, right? Let's see who's attentive in the session now. So if this is my indexing and slicing, before the comma, I'm talking about the 0th row. Agreed, learners? So this is 0th row, like this. And which columns am I talking about? What does 3:5 mean? Slicing is also same as the basic. What does 3:5 mean? What does the slicing mean? We are talking about the, very good, Meera, third and the fourth column, right? So in this row, we get the elements as 3, 4. Very good. So are you clear with this answer? Now tell me which row are we talking about? Tell me the row that we are talking about in the next question. We start from the fourth and we are talking about fourth and fifth row. Agreed, learners? Fourth and fifth row. Similarly, we start with fourth. We are talking about the fourth and the fifth column. So therefore, we get these points. Clear? Got it, Vaibhav, Neha, Bhumika, Prajwal, Meera? Yes or no? Only Neha got it? Vaibhav only got it? Now tell me the answer for this question. Tell me the answer. Which rows are we talking about? Which rows are we talking about? All the rows. Very good. So we are talking about, and which column? Second. Very good. Very good. So we are talking about these elements. Got it? Now tell me the last one. What is the concept that is getting used? What are these two colons known as? What is the concept of two colons known as? And an end position, we are talking about slicing. If we have a step parameter also, what is that known as? Yeah, what is that concept known as? Good, Meera, it start, stop, and step. But what is it known as? What is that concept known as? Striding. No, that concept is known as, please remember that, that concept is known as striding. Okay? Please remember. So, in this case, we start from the second row, jump two parameters. So, we are talking about the second and the fourth row. What about columns? We start from the 0th column, yeah. So, and jump two parameters, 0, 1, 2, 3, 4, and 5. So this is 12, 14, 16, 24, 26, 28. Getting this point? Have you been able to check the output? Understood the output? Meera, Vaibhav, Neha? Yes? Or do I need to repeat it, Vaibhav? Again, this is my starting position. I start from the second row. There is no parameter over here. It will go till end. And the jump parameter is 2. Here, there is no starting position. It will start from 0, go till the end, and the jump parameter is 2. Now clear? Everybody to be concentrated here, and then we will go in for a break, because now we need to understand how does the three-dimensional array slicing indexing works, right? We know that in three-dimensional array, there are three parameters or three axes which define that. Axis 0 selects the matrix, which is the slice of the bread that we want to work on. That selects the matrix. Second index is J, which selects the row. And the third index K, which selects the column. First point is getting clear. The first parameter over here is not the row, but it selects the matrix. J, or the axis 1, selects the row, and K selects the column, right? So if I have this example, how is it represented? It's like NumPy array, three-dimensional array. That's how it is represented. And that's how even a colored image is represented with the channels R, G, and B, right? So three-dimensional array is an example of a colored image, okay? So now let's take this example. If I want to access 2, 0, 1. What does 2, 0, 1 mean? That my value of I is 2. The value of J is 0. And the value of K is equal to, here. Learners, are you there with me? So now when I look at I, J, and K, right? So if I look at I start from here 0, 1, and 2. So which matrix am I talking about? I'm talking about this matrix. Clear? Then it talks about rows. So if I talk about the rows, I'll again start from positive indexing 0, 1, and 2. I am talking for this particular matrix, this particular row. Clear? Is this point getting clear to everybody? When I talk about k, k is equal to 1. That is 0, 1, and 2. So first column, so the element 31 gets picked up. Got it, Meera, Vaibhav, Neha? How the three parameters are doing indexing and slicing over here? And taking it forward, if there is slicing and striding, please look here now. This first comma before the comma is representing my I. This is representing my J. And this is representing my K. This is I, J, and K. All right. So this is slicing happening over here. Since there is no starting point, it talks about the first two planes. That is 0, 1. The 2 is not included. Clear? When I say about J, it talks about the rows 0, 1, and 2. So it starts from 1, goes till n for this matrix as well as for this matrix. So whatever matrix has been selected, that many rows will get selected. And if I talk about columns, it is 0, 1, and 2. So we start from the 0th row. First column, 2 again is not included. For both the matrices 0 and 1, therefore we get the output as 13, 14, 16, 17, 23, 24, 26, 27. Clear? Is this point getting clear to everybody? Or do I need to repeat it? Tell me, Vaibhav, Meera, Neha, Bhumika. Quickly. Understood indexing in 3 dimension. Tejas, Varsha, Manya, Monica, Nagendra, Malika Arjun, Chetan Kumar, Aishwarya, Abhijita, Ashish. Are you all getting this point or not? Let me quickly repeat the 3 dimensional array for all of you. Let me quickly repeat it. So whenever we are talking about 3 dimensional arrays, 3 dimensional arrays are, represented by 3 axes. Axis 0 represents the matrix. J is axis 1, which selects the row. And K represents the axis 2, which selects the column. So if I have these 3 values, okay, I is 2, J is 0, and K is 1. So I is selecting the matrix. So we start from 0, 1, and 2. So over here, since 2 is given, we are selecting this particular matrix. Got it, Abhijita? Manya? Tejas, got it? Now J represents the rows. So again, I do it as 0, 1, and 2. So I'm talking about this 0th row. Now clear? And if I say K is equal to 1, K represents the column 0, 1, and 2. So K is 1, I get it as 30. Now better, Tejas? And if we look at over here, there is this slicing happening for I, J, and K. So if I talk about slicing, it starts from the 0th matrix. 2 is not included. So I'm talking about the first two matrices. When I talk about the rows, it is 0, 1, and 2. So I'm talking about the first two rows. And column, again, I am talking about the first two columns. Rows, I'm talking about the last two, and columns, I'm talking about the first two. Therefore, I get the output as this. So NumPy practically in today's world of data science has a lot of practical applications in terms of data analysis, finance, machine learning, NLP, signal processing, astronomy, physics, climate science, robotics, chemistry, biology, etc. Right? So can we add the elements directly? Yes, if I add the element at array position at 0, at one position is 2, and at 0 position it is 1. So 1 plus 2 will give me the output 3. Are we clear with this particular output also? And if we talk about two-dimensional arrays, then we have to pass two accesses. That is, before the comma, we are always talking about the row, and after that, we are talking about the column. So at the 0th row and second position, we get this output. Right, learners? You can also paste it over here, play around with the code, learners. As I've been telling you, start playing around with the code. Yeah. So we get this element over here at 1, 1. So at the first row, this is my first row, and this is my first column. So the element is 5. Clear? Indexing is clear to everybody. Similarly, for three-dimensional array, we can access the elements using 1, 0, 0. Who's going to tell me the answer if I change it to 1, 0, 1? Tell me quickly. What is the answer for the values 1001? Tell me. Code along with me. If this is my array, what is the output with 1001? Is it 8, Vaibhav? Only Vaibhav has done it. Is the issue? What is the error? I missed out the square brackets. Yes, the answer is negative also exists over here. So when I do negative indexing for the one-dimensional array, I get the answer as 4. Even is a mixture of positive and negative indexing allowed? In arrays, is mixture of positive and negative indexing allowed? Yes. It does not give me an error. All right. Clear, learners? And again, you have this assisted practice. Everybody has got this assisted practice. Will you? So there is a lot of assignments to be done in the file 3.02, 3.03, 3.04, 3.05. So you have 4 assisted practices to be done. So now let's move on to 3.05. Slicing. What is the concept of slicing? Yes, learners, what is the concept of slicing? that we have a start and an end position. If the start position is not specified, by default, it will start from 0. If the end position is not specified, it will go till the end. And if there are 3 parameters, start, end, and step, what are they known as? Start, end, and step. What are the 3 parameters known as? Very good. Only Vaibhav understands, nobody else. That is known as striding. Clear? Clear to everybody? So let's start with slicing over here. Yes, learners, are you there with me? So this is my array. This is 1:7. So it will start from which position? This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. And this is 8. So we start from 1. And the 7th one is not included. So the answer is 4, 3, 5, 6, 8, 9. Agreed? Tejas, are you getting it? Abhijita, anybody having any questions, any doubt, please let me know. Is the code matching now, Meera? Is the code matching now? Neha, is the file matching now? Okay. Listing of 5 colon. This is again slicing. Start from 0, 1, 2, 3, 4, and 5. Since the end is not specified, it will go till the end. So the answer is oops, Java, and cloud. Clear? Right? What is this? Striding. What does striding mean? That it will start from the first position, 0, 1, 2, 3, 4, 5, 6, and 7. It will not include the 6th. It will start from first and jump. So 1, 2, 3. So the answer will be 7 and 4. Output is getting clear? Everybody? Are you there with me? Is the output getting clear to everybody? And similarly, when I talk about two-dimensional array, if I talk about two-dimensional array, so here we are talking about the 0th row and which columns? 0, 1, 2. So the third is not included. So only the second column. So the answer is 33. Clear? And similarly, when I talk about this three-dimensional array, you can print that. We get this answer as 5 and 6. Why are we getting it as 5 and 6? Please look here. This is my 0th matrix. This is my first. So we are talking about this matrix. Okay. I is clear. J is 1 colon. That means we are talking about this particular row, 1 colon, right? And if you're talking about columns, so 0, 1, and 2. So it will start from 1 and 2. So the output is 5 and 6. Clear? Got it, Abhijita, Vaibhav, Meera, Prajwal, Neha, Bhumika? Or do you want me to repeat? Tejas? Tell me quickly. Are you all able to run it practically? And if we talk about negative slicing and like 0 to -1, this part is not getting printed. So if we look at the last thing, do you have the assisted practice for this? Do you all have the assisted practice for this? This is the negative slicing. Will you all be able to do it? Yes, learners, will you all be able to do it? 4 assignments, 3.02, 3, 4, 5. 4 assignments in NumPy that will be discussed in the next session. Faculties, please make a note of that these assignments needs to be done by them. Got it? All right. So now before we move ahead, let's do a quick knowledge check how well you have understood about NumPy, and then we will start with Pandas. Right. What is NumPy and what is it used for? Yes, learners. Quick response. Yeah. So you answer, everybody's answering B. Great. So the answer is B. Yes, it is used for mathematical operations in science and engineering applications. Second question, what are the key attributes of n-dimensional array? What are the key attributes of n-dimensional array? Abhijita, that was quick. What about others? A, B, C, D. Quick. Yes, Chetra, good Neha. It is n dimension, which gives the dimension, shape, size, data type, and item size of the array. Okay, this is a good one. Which of the following is used to change the dimension of the array? Any dimension, not specifically to a particular any dimension of the array. Which is the correct answer? It is absolutely correct. A, the reshape function. Transpose will only interchange the rows and column. Flatten, as I told you, will convert always into one dimension. Good. So are we clear with NumPy, learners? So now we'll move from we did the NumPy. So what was the basic advantage of NumPy? What was the basic advantage of NumPy that you saw, that why this library has been built? Great, Ishan. Great. Yeah. Give me the biggest advantage of the NumPy library. Speed for what? What speed? Mutable is not the correct answer, Abhijita. Even list is mutable. Dictionaries are mutable. That's not the correct answer. Speed and what, Vaibhav? Be very clear and specific. Please be very clear and specific. Faster in accessing, doing arithmetic operations. You can say faster in doing arithmetic calculations. Can we say that? That's why it's a numerical Python. And what are the two concepts for doing arithmetic calculations? What are the two concepts for doing arithmetic calculation? The concepts in NumPy library, I told you not to forget those concepts. Come on, quickly answer. Nobody? Broadcasting and vectorization. Broadcasting means having arrays of the same shape and size, and vectorization is element by element operation. Very good. Good. Now, another most important library of Python, that is the Pandas library, without which no data analysis can be completed. So if you say, I know data analysis, it is assumed that you understand this Pandas library. Why is it important? Because it helps to represent the data in the form of tables. When we say tabular data, that means data in the form of rows and column. This is how we generally see the data in terms of SQL Excel files, that these are my rows, right? And these are my columns. Agreed, learners? This is what we generally see as data, structured data, to put it more precise. That's how. So a column is generally of the same data type, right? Right. And this can be represented as a one-dimensional array, right? And the whole of the table can be as two-dimensional array or in the form of matrix. Can we say that? So here we give them specific name. One-dimensional array in case of the Pandas library is known as the series function, and two-dimensional array is known as a data frame. Please try to understand. So the two data structures available in the Pandas library are Pandas series and Pandas data frame. Pandas series is nothing but one-dimensional labeled homogeneous array where the size is immutable, and the data frame is two-dimensional labeled array which is a mutable structure. Now the question arises that when we already had one-dimensional and two-dimensional array, right, then what was the need of these data structures? So the need of these data structure is in their label indexing. Please try to understand. Here there are two types of indexing available. We can define our own label. That means here we don't have to give 0, 1, 2, 3, but every column will have its own name or index. So the column name is known as the label index. And similarly, I can give my own names to the rows also. It is not necessary that it will be 0, 1, 2, 3, etc. Clear? Is this point getting clear to everybody? Right? So let's start with the first data structure of this Pandas library, that is a Pandas series. Series is nothing like a column in a table, and it is a one-dimensional array holding data of any type. Over here we see it as the default indexing, but you can define your own labels also. Getting my point? You can define your own labels also. All right. So a series has a series name, a values associated with it, And of course, you can define your own index value, right? So how do we go about it? I want everybody to open their Jupyter notebook and start writing this code. The first thing that you will write, I want everybody to do this activity. Import pandas and PD. Everybody open your Jupyter lab and start working on this activity. The first line is going to be importing of the library. That is import pandas as PD. And here I am creating my two lists, one with the name temperature, other with the days. Quickly, I want everybody, let me see, paste the code initially. And the function which is used to create the series function is pd.series with the value temperature and index equal to days. Got it? And now you see the output. The output is vertically aligned. First difference. And rather than having my index as default 0, 1, 2, 3, I get this as Monday. The temperature is this, Tuesday. Anybody who's got this output? Quickly. Who's pasting the code first? Vaibhav, Meera, Neha, Suhana. I want everybody to work on this activity. So Naina was quick. So have you been able to do it? Series from the list. Now I want you to change this code right over here as days, comma, and write index is equal to temperature. Do that for me, Naina. And then give me the output, then check the output. Good, Naina. Interchange the attributes of the series function, parameters of just interchange them. Very good. Excellent. Right. Right. So do you see that the rows have interchanged? This becomes my index and Monday comes over here. Right, Naina? This is the output you get. Interchanged output. Good, Abhijita. Very good. Very good. So you've done it. Very good. Others have done it. Meera, Vaibhav, Neha, Bhumika. The Pandas library is built on the NumPy library. We have these two series, S1 and S2. And when I do S1.S2 add, we see that the elements are getting added element by element. So it uses the concept of broadcasting and vectorization. Well, not broadcasting because both of them are of the same shape. So it is using the concept of vectorization. Now quickly run this activity. Quickly run this activity. Does it first. Sahana, do the code quickly. Addition of these two series. Very good. Very good, Meera. And similarly, you can do S1 to subtract S2. Good, Meera. You're getting this output? And if I do not pass any index value, I get default index value as 0, 1, 2, 3, 4. And by default, it gives me the data type of these values. By default, it gives me the data type of these values. Getting my point? So Pandas is nothing but an open source library built on top of NumPy and is used for data manipulation. It introduces data structures like DataFrames series that make working with structured data much more efficient. And the advantages are that alignment, it gives the data type along with it. Also, it uh, me data standardization. It's a structure, intrinsic data alignment along with your label index. That's the advantages of the Pandas library. The two data structures available in the Pandas libraries are series and data frame. Series is one-dimensional labeled array, supports multiple data types, and data frame is two-dimensional array, right? Which can be a combination of series also, right? So now let's start with the very first code. So first thing, what is the first step that we need to do? We need to import the Pandas library. What is data? Can you tell me the data type of this data? What is this data? It's a list. Index is also a list. So now pd.capital series data is, I pass it as my data, and index I pass it as ABCD, and that's how I can check my output. What we can do is I'll just do a copy paste so that it's easy for us to just understand the outputs. So just you can paste it and then do series with index. Do you see this? Index is A, B, C, D and output is 1, 2, 3. Yes, learners, I've just done a copy paste over here. Nothing more than that. If you want, I can just show it to you. Paste it on the chat also. Yeah. So this point is getting clear. We can also create series using dictionary also. The beauty with dictionary is that, the keys become my index. The values become my data. Right. Do you see this? Both are giving me the same output. Learners, are you there with me? We give it with index. Yes. Are you able to do it? Vaibhav, Naina, Bhumika, Neha, Meera, Chetra. So Pandas series can be created through list as well as through dictionary. Do you see this? This can be created with a specified index or list as well as through dictionary. Getting my point, learners? And how do we do indexing? If I want to access any of the elements, default indexing is also there. That is 0, 1, 2, 3, 4, and 5. So it says to get the value 2. So it will give me the value 3, or I can access only the element for B. Clear? Series with index and series with data. Okay. So this was print series. Yeah. You see the difference? If I do not pass the index, please try to understand over here, learners. Just add a print series over here. If I do not pass the date index, it will by default give me 0, 1, 2, 3. And if I pass it with index, then it will use the index value. Clear? This point getting clear to everybody. Now let's understand some basic functions in the series, right? In the Pandas series. These functions collectively help analysts summarize and understand the characteristics of the data, facilitating effective data exploration and data analysis. So please try to understand these functions. Everybody to be concentrated over here. Very, very important functions which will be used in data analysis. The first is this head function, which gives the first n rows. If I have passed the parameter 3, it gives me the first 3. If I pass it as 13, it gives me the first 13 rows. And if I do not pass any parameter, default value is equal to 5. Okay. Then the default value is equal to 5. Tail is the last 3 rows. Shape gives me the dimension, rows of column. Of course, when we are talking about series, series will always be one-dimensional array. Agreed, learners? Series will always be one-dimensional array. When I move ahead to the describe function, it gives me the statistical analysis. Uniques, it gives me the unique value of the function. Please use these functions, and NUnique gives me the number of unique values. Got it, learners? So it doesn't print anything. So we can print one of them. So what I can do is, learners, you can also make the changes in the file. That's why I keep making changes in the file. So it becomes first. So do you see it gives me the first n rows? And if I change it to 13, since there are only 5 elements, it will give me 5. And the moment I change it to 1, it gives me only 1 element. Clear? Are you all getting this point? Learners, are you there with me? And then we go in with last n, the last 3 rows. So I'm just cutting one of them. You can also do it along with me. Meera, are you able to do it? Vaibhav? I'll share this file with you. It gives me 5 elements. Describe gives me the stats part of it. Just copy paste it. That's it. Just print the outputs. It gives me the average values. Have this. Unique values. So 1, 2, 3, 5 are unique values, and this n unique gives me the number of unique values, which is 5. Clear? Vaibhav, are you able to do it? Neha, Bhumika? Now I've just broken those information and seen the output. Just simple functions. Got it? Now let's understand the operations and transformations in Pandas series. Operations and transformation in Pandas series are crucial for modifying and enhancing. All these operations help in cleaning of the data. So if I want to see the element by element addition, series plus series with index, right? So basically over here, it will, if the indexes are common, then only I will get the output. Yeah. So 0, 1, 2, 3, and then the other one is A, B, C, D. None of them are common, so I get the output as NaN. What does NaN stand for? Not a number. Then I am doing the squared of the values. Again, I'm just doing just copy paste, cutting it and just checking out the output. So it gives me the squared of the values, the map function. Right? Since I have given that 1 will become my 1, right? So wherever the value 1 was there in this series, let me get back to that series. Yeah, so this 1 gets the number 1, 2 gets number 2, and 3 gets number 3. Clear? Similarly, by using sort underscore values, we can sort the values also. Well, it is already sorted, so nothing to be missed over here. Just to check on the null values, you can use the null. So these are the functions which give power to the Pandas library for the analysis. So there aren't any missing values. So the answer is going to be false, false, false. Right. And finally, it is if there are any missing values, null value, it will replace it with 0. So we will do a lot of, practical, data with this. So nothing to worry. So nothing changes. So are you there with me? Got it? So just to recap, basically you can do element-wise addition in series, apply each of the function mapping using dictionary values, sort underscore values to sort the data, and to check the null value is the isNull function. Yeah. Are we good to go? Can we move on to the next file? Not the next file, next topic, that is querying a series. So if this is my series right over here, if we check out the values greater than 30, it will give me only those values greater than 30, lesser than 30, right? So these are the outputs. So this is my series, the original series, and I want to see only the values greater than 30. I just have to apply the conditional operator. It has print below, right? So series indexing, only those values greater than 30 get printed. Values only equal to 20 get printed. Values not equal to 40 get printed. Values greater than 20 and operator is also clear. Lesser than 50 get printed, right? And is in. One of them is series and the other one is data frame. Series is one-dimensional array. And we also understood data frame as two-dimensional array, right? And how is Pandas library different from NumPy? Can you tell me quickly? What are the distinguishing factors, Neha, Sahana? that we can define our own labeled access, right? Do you remember that? We can define labels, right? So if we talk about Pandas library, they help in manipulation of real-time data in which is represented in terms of rows and column, right? Right? And the two main data structures in the Pandas libraries are series and data frame. Series are one-dimensional homogeneous arrays, whereas data frame are two-dimensional size mutable tabular structure with potentially heterogeneously typed column. Getting my point? Have we all done series? Do you remember that particular file? 4.01 that we had completed. The Pandas series is nothing like a column in a table, and it requires the index that we can define our own along with the value. So you remember this practice activity that we had done, that these are to my list, and pd.series is the function. This is referring to my data, and these refer to my index value. Yes or no, learners? Am I audible? This is the index. So these are nothing but of my integer type data, and this is nothing but your label index. Another important property of Pandas is that all the data is vertically aligned. A series will always be one dimensional, and this was missing in the NumPy files. And since the Pandas library is built on NumPy, we can easily add s1.s2. Here, the important point is that the index numbers should be similar for addition of the series function. In this whole journey of data science, it is important to understand the concept of statistics. Can you tell me the Python function which gives the statistical details? Anybody who remembers Python function that we have done, detail of these values? Anybody who, which is the Python function which gives the detail of statistical values? Yes, learners. Function of head. What does the head function do? Yes, learners. Do we remember head gives the top 5 values by default? Do you remember tail? Yes or no? Nobody remembers? I think so. We need to do it today. And then did the describe function, right? Which gives the, the mean, the standard deviation, minimum, maximum, and the quartile values of the, getting my point? You all there with me? Mean is nothing but summing up the value and dividing by the total. Standard deviation tells me how far away from the mean. Then we have the quartile value 3. So this is the function that I'm talking. Learners, please look here. If all the values are numerical, describe function gives me count, mean, standard deviation, minimum, Q1, Q2, Q3, and maximum value of the data, right? And if we talk about if all the values are characters as P, P, Q, R, and if we do the describe function, and if we do the count value, it gives the 4 letters. Unique gives me how many unique values are there. Top gives me the top letter is P. Frequency gives how many times the top item has been repeated. Now moving ahead to the next concept today, that is data frame. Data frame is nothing but a two-dimensional data structure. That is, data is aligned in a tabular fashion in terms of rows and columns. So data frame is nothing but a two-dimensional data structure. That is, the data is aligned in tabular fashion of rows and columns. Data frames are, are of different types because every column is different. It could be one of them could be int, float, or string type. Definitely, data frames are mutable. They have the labeled access in terms of rows and column, and it can perform arithmetic operations on rows and columns also. Getting my point? Right? So if we talk about the concepts of data frame, we understand axis 0 refers to the rows. Please be clear. Axis 0 refers to the rows and the values can be accessed via df.index. Okay. And columns refer to axis 1 that is represented as df.columns. And all the values in the table are can be accessed with the help of df.value. And each column has its own data type. Is this PPT getting clear? So data frames can also be created with the concatenation of two series function. Getting my point? Let me see the new file. Okay. So are we clear with the key features of the data frame, that it is organized as tables and rows, labeled axis, it has heterogeneous type of data, it is versatile also, right? Now, do you see this particular data set? This is the file, learners. Do you see this file? So the first way to create, data frames is, can you tell me what is the data structure? The first way to create data frame is using dictionary. Learners, are you there with me? The first way to create dictionary is creating data frame is using dictionary. First thing, import the pandas as PD, right? Secondly, the key values automatically become my column heading, and these are my list or the data points. Getting my point? This is nothing but my data frame, pd.data_frame. Everybody is able to run the code. I've just split the code so that it is easier for us to understand the different ways to create data frames. Data frame is using the list of list. Yeah, do you getting this? So this is pd.data frame. This is the data list and this is the column list. Are you understanding the different ways to create data frames, learners? Are you able to run the code along with me? The way to create is array. What is the dimension of array that we are using over here? What are the dimensions of array that we are using over here? What is the dimension of this particular array? Quickly tell me. np.array creates an array. What is the dimension of this array? Two square brackets, what do they represent? Yes, it's a two-dimensional array, which helps us to create the data frame that's a tabular structure. And another way is by reading a CSV. Should I share this CSV file with you all? I'm sharing the CSV and Excel file. Please download it and copy it into the same folder. So when I load this, this will run. It will not run because it's not there. So let me see. This is house prices. Please download this particular file. You'll find all these files in the dataset folder. And then we have the iris folder. Once you have downloaded it, it should be present in the same folder. So how do we go about it? I'll do just a copy paste over here. Right, learners, are you there with me? Do you see I've already copied the CSV file in here? And now if I run my code, it's able to give me the output. Do you see this, learners? Learners, are you able to run this, load this houseprices.csv? Only Sahana is able to do that. What about others? Anybody who's not able to do it? So data frames can be created from dictionary, list of lists, NumPy array, reading the CSV file, reading the Excel file, right? And when I read this Excel file now, the iris.xls, that's how I get the output. Got it, learners? Anybody with the thumbs down who's not able to run this code, please let me know. Data frames is getting clear to everybody. Right? Now, getting back to the PPT that I'll be sharing today on the LMS for the pandas. So this is what it is, that data frames can also be created by simply using the pandas read underscore CSV function and passing the path of that CSV file. So this columns get converted into a data frame along with rows and column. Clear? And another way that we have understood is using a dictionary. The keys become my column heading, and it is the head function which gives me the top n values. Got it? Right? Now, who remembers that what are the types of indexing available in basic Python or NumPy? Anybody who remembers that what are the two types of indexing available in basic Python or NumPy? Nobody understands basic indexing. It refers to positive indexing as well as negative indexing. Please look here. What does it mean? We move ahead with positive indexing as well as negative indexing. But Pandas library is different, right? Here we can define our own labels. So how do we give the indexing part of it? How do we give the indexing part of it? Tell me quickly. That's known as label indexing, represented as .loc, and integer based or position based indexing known as ILOC. Do you remember that point in series or not? Yes, learners. NMIT students, are you there or not? So, label indexing refers to the label or the values that we have given. Column value index, they refer to the .loc values. Row index values refer to LOC, right? And by default, even position-based integer indexing are present that can be accessed via ILOC. Got my point? Getting my point? Explaining this with further example, let me move ahead. that indexing in Pandas can be label indexing or position based, right? Label is what label we have explicitly given to the rows or column. Definitely columns have name, but if there are no names given to the rows, it will take 0, 1, 2. Okay. Do you remember this type of indexing? This type of indexing is used to extract multiple values. This type of indexing is known as list indexing. If I want to extract more than value. And another important point, slicing. Slicing is extracting the part of the number of columns, right? So here we have 0 to 2, right? Over here. But another major difference between label and position based indexing is that in label based indexing, 0 and 2 both are included, whereas in position based, this 2 is not included as in normal and basic Python. Got my point to everybody? Can I get a response? Are you understanding? Or do I need to repeat this? What do I mean over here is that slicing over here means that 0 to 2, the labels that we have given to the column. But in this case, 0 and 2 both are included, but in integer based or position based, it's like the normal slicing. Only in 0 and 1 are included, 2 is not included. Now clear? To make the concept even more clear, let's understand with an example. So if this is my data frame, the first bracket, please try to understand this. So the first one is known as for the indexing. The first square bracket is used for indexing and the second square bracket is used for the list. Getting my point? This is known as the list and this is used for indexing. So what does it do? That it extracts the two columns automatically, that is employee ID. If I want to extract age, that I can also add. Getting my point now? Right? And if I say integer based indexing with 0th value, it refers to the first row because here I am, can you tell me data frame? Data frame is like 2 dimensional element is like row, comma, column. So if there is no comma given, so it becomes row, comma, C. Getting my point? Right? But again, if I want to extract multiple rows, again, I can use the concept of list indexing also. Now getting clear, Sahana, Aishwarya, Neha, Naina, right? And do you remember this concept now, learners? Do you remember this concept? This is label-based indexing. If there are two colons used, what is this known as? If there are two colons used, what is this known as? Anybody who remembers the concept? I explained. This concept is known as striding. It's not string, it's striding. Okay. So the last is the step parameter, right? We start from the 0th row, right? And we will jump to values. So what are the rows that we can get? We get 0th, second, and the 4th row. Got my point, learners? Since this is before the comma, this refers to the rows. And this is after the comma, it refers to the column. So over here, what is the idea? That the employee ID is also included. The skill is also included as well as the age is included. This is another difference. I hope this example in the PPT is making the concept clear. Yes, learners. Getting my point? Is this point getting clear to everybody? Got it, learners? So now let's get back to the practical file. So the accessing of the data frames is possible. Elements in Pandas library is based on two indexing. One is known as label indexing, and another way is known as integer based indexing. Can you tell me how are we creating the data frame over here? How are we creating the data frame over here, learners? Which data structure are we using? What is data over here? Quickly tell me. We are using dictionary to do that. So I'm just separating the code. If you want, you can do that. But so that gives me, a little more better, easier thing. Or if I remove this, this is how I get the data frame. Clear? Yes, learners, are you there? Everybody's able to run the code. How can I access a single column? Just by giving the column name, it prints me the column data. If I want to access multiple columns, I can use the concept of list indexing. Clear? Difference between accessing single column and multiple columns is clear. Everybody is able to get this point just by single column name. And if they are multiple, then I can add the list onto it. What is ILOC? Integer based indexing, where I access the specific rows. The first row is given as the output. Everybody is able to run the code along with me. Yes or no? If I want to access the rows based on condition, I just do it because I think so it's easier to run the code and get the output rather than first see the code and we would keep on doing the scrolling. That's why I'm just cutting the code and checking, giving you the output. So only those columns get printed with column name greater than 15. Got it, learners? Another way to access single cell by label is using is at. This is the 0th column and the column name, or we can also give the index value. Both will give the same thing, or we can also use the label index. So I think so 3 will give me the same output. Yes, learners, do you see the output? This is 5, this is 10, this is by label, and this is LOC. So why the position is not giving me the output? Position is not giving me the output because if I give 0, then I will get all the same values. Clear? So you would say that, ma'am, what is the use of label or integer base? They are exactly same methods, but different ways to access the data. It's completely up to you. You want to use the index position or the label position. Clear? Getting my point? Is this point getting clear to everybody? Neha, Meera, Gautam, Sahana, Hamshika, Malatesh, are you there or not? If I want to do certain kind of conditional access, that can also be done. Clear? Are we good to go, learners? Still waiting for the response. Everybody has been able to run this code or not? Waiting for the response. Abhijita, you were able to do it. That's great. What about others? Are you all there in the lab? 100 plus. Oh my God, you've got 120 now. Come on, learners, respond. At least 50% of you respond. Manvit, Manya, Maruti, Meera, Monica. Quick, quick, quick. Prajwal, Prakhyat, Pragna, Purnesh. Come on, respond, everybody. Shreya, Shivaraj, Shashank, Saswat. Okay, great. Now, understanding the data frame basics, the commands remain the same whether we are talking about the series or data frame. The head and tail methods enable users to efficiently preview the initial and the final rows of the data frame, offering a quick snapshot of its structure and content. These functions are invaluable for preliminary assessment. So now this is the power of Pandas library. When I say that Python is a good language, supports simple function, so this is where the power of Pandas library. Head function. Please be clear with these functions, everybody. It returns the first few rows. Tail gives me the last few rows. Info provides me the summary of the data. I asked about describe. It gives me the statistical summary in terms of count, mean, standard deviation, minimum, maximum, and quartile value. Then we move on to the shape, which gives me the number of rows and column in the data frame. And without these functions, no analysis is complete. Column gives me the returns, the column labels, LOC and ILOC are the way in which we can achieve indexing and slicing of rows and column. Sort underscore value will sort the values, group by will group them. Apply applies each function to each element. Merge and concatenate will merge the data set. Plot will plot, and drop removes the specified row or column. So we will, as we move along, we will explore these functions, right? So if this is my data frame, please look here, learners. Again, I want everybody to look here. So if this is my data frame, right? What will the head function do? Come on, tell me. What will the head function do? Since I've passed two parameters, it will give me the first two rows. If I have passed only one, it will give me the last row of that particular data frame. Then if I give info, it provides the comprehensive summary of the data frame. And here it returns a tuple representing the dimensions of the data frame. Learners, are you able to run these first two rows? The info. Have we understood this basic operations? Head, tail, info, shape. Now coming on to the most important part again, statistical operations which give the insight into this data. So if we talk about descriptive statistics, which is the function which gives me the details of descriptive statistics. Come on, learners, tell me. Which is the Python function which gives me the detail of the descriptive statistics. Please remember this function. Okay, Sahana, Neha, Gautam. Hamsika, Malatesh, please remember, which is the function, Python function, which helps us to calculate the mean, median, and standard deviation. This is exactly the same function that were present in NumPy. df.mean gives me the means of the value, median gives me the median, and std gives me the standard deviation of the value. Getting my point? Is this point getting clear to everybody? Are you all getting this point? Now, the most important thing is correlation analysis. Let's try to understand correlation analysis. Okay. Now, there is another important parameter which is part of the data frame that is known as the in place function. How will you override the existing data frame? So, do you want to override the existing data frame? If yes, then we will always make the in place parameter equal to true. And if we do not want to make the changes permanent, then we will make in place is equal to false. So that we will see once we do it practically. But before that, we need to understand correlation. Another very important aspect of statistics. Please try to understand. This is the formula for R, that is Pearson's correlation coefficient. What does it help us to do? It helps us to find out the relationship between 2 to 3 variables. So Carl Pearson's coefficient of correlation, where value ranges between -1 to +1, which tries to give the relationship between x and y. So what does -1 represent? -1, if the R value of the R is -1, it shows a strong negative correlation between x and y. What does negative relationship mean? That if x increases, y decreases. All right. On if y increases, x decreases. That's the negative correlation. And when R is equal to +1, what is the positive correlation mean? X increases, y also increases, or x decreases, y also decreases. Getting my point? That if x decreases, then y also decreases. Getting my point? Is this point getting clear to everybody? And when R is equal to 0, that means there is no relationship between the data points. Got it, learners? Very, very important to understand the in-depth of the column. For example, if this is the data that has been loaded for your maths, physics, and history marks. Simple example I'm giving. Simply, we have loaded the CSV file or the Excel file containing the marks of maths, physics, and history. And when I run the function df.core, it tries to create an n by n matrix. Please try to understand. Since there are 3 columns, so a 3 by 3 matrix is created. What is the use? It gives me relationship between maths and maths. Of course, diagonal elements is going to be 1 because we share positive relationship with ourselves, right? We are perfect with ourselves. So there is this perfect relationship between 1 to 1, right? But what is the relationship between maths and physics? It's very strong. It's very close to 1.9. But the relationship between maths and history is negative with each other. Similarly, if we talk about history and physics, they also share a negative relationship with each other. Getting my point? Is the correlation getting clear to everybody? Have you understood what do we mean by correlation? Sahana, Meera, Nagendra, Naina, Neha, right? Then there is this another function value underscore counts, which helps us to calculate the unique value. So based on the categories, they are north, east, west, and south. How many times east has been repeated? Only 2 times. How many times north? 1. How many times south? 1. And west was 2 times. Got it, learners? Is this point getting clear to everybody? So getting back to the practical file. So which is the Python function which gives the correlation between the values? Yes, learners, which is the Python function which gives me the correlation between the values? It is df.core. And what is the range of the values? The range of the value is always between -1 to +1. Here they all share a positive relationship. But if I want to make it to negative, yes, Aksha, there is some issue. Yeah, it's df.core. And if I really want it to be negative, maybe I can put a negative sign over here, then run and see the output. So between column 1 and column 2, there's a negative relationship, but 1 and 3, share a positive relationship. 2 and again, 2 and 3 share a perfect negative relationship. And that is true also. Clear? Then we understood value underscore counts, which gives me the categorical data along with the frequency value. Are we clear with this particular point? Are the concepts clear? Are we able to run the code? And this is the assisted practice for you all, that you have to load the housing data set and then perform such actions on it. Will you be able to do that? This is the data set. You can save it for your homework assignment. Got it? So what is the use of datetime function in any coding language? Can anybody tell me? What is the use of datetime function in any coding language? No? For example, if I, now look at over here, I am creating this. Do we have any date type over here? What is the date today? Let me put that as that. 0403 and 2026. All right. Now suppose if I don't give the code, okay? Right. Do you see? It doesn't allow me to even print this. Suppose it's saying that no literals are allowed. It doesn't allow me to give three. So let me remove this. So it works. Let's see. It's minus 2025. What does this minus 2025 mean? We are not even getting the correct answer. Learners, are you getting it? So that is why a library has been built in Python to deal with date time objects. It is nothing but an integer data type, right? Got it, learners? And if I do a date plus 1, do you think I'm getting the correct answer? Do you think I'm getting the correct answer? No. Right? So that is why to deal with date time, most of the time the real time projects will contain columns which are, of date and time. It could be arrival, departure of the flight, when that particular recording was done, how long the session went on, right? And who bought at what particular time, when the items were sold, whenever they were shipped. Every real time data requires this date time analysis. Got my point? So in Pandas, the datetime module provides robust functionality for handling date and time. So Pandas library, because Pandas is a library which helps in data manipulation, real-time data. So in Pandas, the datetime module provides robust functionality for handling date and time data, while the time delta class allows us for convenient manipulation of the time interval. This combination is particularly useful for time-based analysis and working with temporal data in the data frame, right? So if I want to access what is the date time now, then what is important over here is that we need to import the date time module. The first thing over here, please try to code along with me, learners. Import date time. Okay. And if I say, I'll just send the code today is equal to date time dot now. Oh, I wrote put it as data. So it doesn't have now, or if let's see then today. It's not working. Let me see. So DT, sorry, this is the accessor, and then we have this as date time dot today. Now, do you see? It gives me today's, what is it? 4th of March, 2026. And if I want the time to be now, how will I go about it? DT dot date time dot now. Got it, learners? Are you getting this point? Are you able to understand this or not? This is the time for today and now. Clear, learners? Neha, everybody's able to run it. Should I copy paste the code? Yeah. I'm pasting this code on the chat. Please run this code. Yes, learners, are you able to run it or not? And if I want to do any arithmetic calculations on that, then I can use this time delta function. For example, if today's date was 26th June, it would have added 6 days to that to get me this output. Clear? Rather 5 days. It is actually 5 days, so there is this error. So it is 5 days which can be added. We'll just see. Getting my point, learners? Are you there with me? So that's why data handling is very, very important because it involves handling of the real-time data set. So first thing, how do we create a date range in Pandas? So the date range function is used to generate a sequence of dates with a specified range. So we can generate sequence of dates. It's a powerful tool for creating time indices or date column. For example, if I want to create dates starting from 1st of January 2023 to 10th of January daily, I can pass this as frequency equal to D. And if you want to start it from today, let's start. Or you might be thinking that, ma'am, do we need to pass always the year? Let's see if I can pass the today's date 04/2/03 2026. And maybe I want to go till 14th, 03 to 2026. So let's understand, is the format important or not? So we are getting a blank index over here. It's not able to interpret the output. So if I give this as 2026, so there is a format in which it understands, right? So 03, and maybe I can give it till 20th, 2026, 03 till 26. Now it gives me the output from 20th to 26th March. Got it, learners? So this is the format in which the date works. It is year, 4 times year, then the month, and the days. Now look at the beauty of this. If I enter a wrong date, for example, in the month of, let's put it as February and put it as 29th. Was this a leap year? No, it wasn't, right? And then till 26. Does it allow us to do that? Let's see. It gives me an error automatically. Day is out of range. Automatically, it will give you the day is out of range. So that is the beauty of using this date time library. Are you all getting this point? What I'm trying to say over here is that if I give 28, it will not give me error. But the moment I give 29th February, which is obviously not a valid date, it will give me an error. Clear? Is this point getting clear to everybody? Are you there with me, learners? Yes or no? Yes, learners, are you there? Maruti, Pranav, Neha, Nagendra, Naina. Okay, so now if I want to extract the part of the date, okay. So what is this? Here I have created a data over here. Again, I'm just doing a cut paste to make it's of object type, right? Or it's like this. Can we do it like this? No, it doesn't work like that. Or does it work like this? Let's see. That it is a series. But I want to know the data type. What is the type of the data? Are you getting this point? I want to know the type of its values. Or if I say values, that's numpy.ndi. No, no. What we are looking as it is AS type. Yeah. Please try to understand, learners. Are you able to run it? Or the one we forgot. It's not AS type, it's D type. So it belongs to object data type. Got it? It's like object data type. Date is object data type. Can we work on this object data type? What I'm trying to say is, can I do df dot date plus 1. Can I do that? No, it will give me an error. So which is the function which will convert it into date time object? This function. Please try to understand, learners. It is this function that will convert it into date time. So now if I check the df date, well, the output will look just the same. Do you see this? Has the output changed? Let's see this. Do you see this? This is year, then this. So this is exactly the way we are going to get the output. Got it? And now if I check its D type, this is of date time object. Got it, learners? Or another way to do it is please look here, learners. What I'm doing is, let me just cut this. Rather than D type, let me do an info. It will give me that this is a date time object, consists of one column. Now I'm adding one more column into the data frame, right? My data frame looks with two columns. And now look at the difference. They both look the same, but they are not. So now if I do a df dot info, the first date is of date time and the second one is also of the date time. Did I convert that? Oh, earlier we have done that. That is the reason. Again, I load it. So this is the df. Again, please look here, learners. I'm going to give you the code. This is the data frame that we created. And if I check the info of this, then this is of object data type. Now I convert this. This is the output. So the first date is now of the object type and this is new one is of the date type. Now clear? Now if I want to extract each individual's day, I can use df.date.dt and day access specifier, then month and the year. So by using these functions, we are able to extract that. What is the error? Okay. So you have to change this to date 1 because now we had changed it to date 1. Yeah. Now do you see this? Got it, learners? Getting my point? Are we good to go? Please run the code and give quick confirmation on the chat. Faculties, please check them that are they running the code or not. If they are facing any difficulty, please let me know. Come on, quickly, learners. Please run this code. Okay. Now moving ahead, and now we have again created a data frame ranging from 1st of January to periods 5. So we will put it as today's date so that we understand the significance better. Okay. So if we see this, this is 4th, 5th, 6th, 7th, and 8th of March. Weekend. Now, automatically what happens is at back end, can you tell me 6th, which is the day on the 6th? 4th is today, Thursday. Friday is 6th. Then we have 7th as Saturday and Sunday. Is that true? 9th is Monday, right? right? So how do we go about it? Automatically, the weekday number, this is at 5, right? And let me put it as 9. Now check it over here. Today is 4th of, oh, it was March. It is 2023. That's what I'm confused with. Okay. Now let's go ahead with this. Right. Now look at over here. Today is Tuesday or Wednesday. So by default, Monday is given as value 0. Please try to understand. How is this datetime module helping us? This is Monday. This is Tuesday. This is Wednesday. And this is Thursday. So Thursday, tomorrow is Thursday, tomorrow is this, then Friday, and Saturday, Sunday is 5, 6. So the moment it knows that it is 5 and 6. How do we know that? If the value is equal to 0, what does equal to 1? For example, if 5 is equal to 1, it is true. That means it's a weekend. And 5 divided by 6 is also 1 point something. Then also it is true. Rest all are not weekends. Are you able to understand this particular logic? Here we are trying to find out weekday and weekend information. So simply by using data accessor weekday and using the logic of dividing it by 5 equal to 1, able to get it in true and false, whether it's a weekend or not. Clear? Is this point getting clear to everybody? I've not made any changes except this date and period also. So now if you put it as 7, now you can see 0, 1, 2, 3, 4, 5, 6, 7. Got it, learners? So again, what is the use of this datetime module? We can convert any datetime module, any object data type, string data type to date type module. And if I want to add and subtract any previous or next date, that can be easily be done by the time delta module. Getting my point? So if that was the previous date on the 1st of January, the 1st January 2023, the previous date, automatically it gives me 31st December 2022. Getting my point? So we don't have to decide the logic. It automatically decides the logic and does the arithmetic operations on that. Got it, learners? Time delta function is used for arithmetic calculation. Can we pass this as months? Days, hours, minutes are allowed. Weeks, days, hours are allowed. Months are not allowed. Weeks, so it talks about the previous week. Do you see? And this is the next day. Do you see the difference now? When I give this as weeks equal to 1, this gives me the previous week. This is how it gives me. Clear, learners? So time delta in Pandas is using to, represent the duration or the differences between the two dates or time. It can be created by specifying the desired duration such as the days, hours, or minutes. So again, what are we trying to do over here? Here I am my data frame with date ranging from 1st of January 2023 to 10 periods in terms of hours. The value 1 is range this much and value 2 is the range this much. So this is my data frame. Let's cut it over here so that we understand it better. Says that future warning, it says do not use capital H, use small h. So please change that. These changes keep happening in the community. Yeah. I'm making the changes in the code. Please make the changes along with me. And now I am adding days 3, creating a time delta of 3 days. So what are we doing over here? Can we do this? Date plus delta? No. Date of what? TF is equal to, no, TF changed date equal to this. Okay, okay. Now you see this. 3 days are getting added, right? I'm just giving you the code. Whatever changes I'm making, I'm giving you the code. Yes, learners, are you there with me or not? Please run this code, everybody. So arithmetic operations can be performed using this time delta function. Got my point? So now if we talk about, have we understood the importance of the date time module? Yes. So basically whenever any CSV file or an Excel file is loaded, the date column is by default of the object type. Please remember this, sorry, that the date time object is by default of the object type. Getting my point? And it is once we use the pandas to underscore data frame function, it gets converted into date time object. And why do we want to convert it into date type data type? We want to convert it so that arithmetic operations can be performed on it, right? Otherwise, it is not possible to do it on the object. And how do we perform arithmetic operations on the date time module? Using the time delta function. Getting my point? So Pandas offers a rich set of functionalities for working with date and time data, primarily through its NS data type, that's the dot data type. And by using the accessor.dt, one can extract the weekday, the day, and the year in the date. By using the accessor.dt, one can extract that. Got it? Is this point getting clear to everybody? Yes? So now we understand that basic class is date time. When I do class date time, okay? For specifically date, we can use the date function. For time, we can use the time function. Then we can combine the two also for the date time function and for time delta function again for adding or subtracting the values. And then we have the TZ info, which helps us to give the for the time zones, right? For my time zone and your time zone can be different. Time zone for Asia, Tokyo, USA, etc. Clear? So first date time is nothing but the module that needs to be imported. Then we have the Python class, and today and now are the Python function which help us to give the date. So how can we create date time object using date or date time class? By using now or today, by conversion of object data type to date time object, or as we have understood using the pandas date time range function, which helps us to create a date range object, right? And if we want to specify the format of date time, you can use now.strf time, or you can also use strp time, right? To convert a string to a particular format. You can change the format of the date. For example, if you want the month before, then the day and the year, that can also be done. Clear, learners? And these are the different percentage: capital Y for 4-digit year, small y for 2-digit year, a small m for 2 month, and capital percentage M is for the minute of the time. So I've added all the description into this PPT. Whenever you need to, if you have any issues, once you go through it again, you will understand it better. When if you have any issues, you can use it, access the data if you have any doubt. And of course, it is the pandas date range function which helps us to create the range of the data. Got it? And extracting the date time component is through the .dt or date access specifier. Clear? So if I have this date as now and I give time delta days is equal to 3 days get added. And if I want to add the number of hours or week or minutes also, that's also possible to add that. Clear? And if I want to add years, then we have now is equal to date util, relative delta years is equal to 2. Clear? Any doubt till here? Right? And you can add, even subtract the days to perform any arithmetic calculations. Clear? Are we good to go, learners? Right? Now, another important concept in when we deal with real-time data is categorical data. What do we mean by categorical data? What are the color of your eyes? Green, blue, black. What is the gender, male or female? What are the grades that you have got? A, B, C, D. So categorical data is not numerical data, but it can be further divided into nominal. That means there is no importance of the order. That is, it could be the postal codes or the gender, male and female, or the order. For example, the ranking that you give or the grades, that A has better ranking than the F grade, or socio-economic status, right? So categorical data needs to be understood. You remember the first session which I had taken, that basically data is divided or understood into two types. The two types of data are numerical and the second one is categorical. Please try to understand this particular point. So data can broadly be divided into numerical or categorical data, and the categorical data is further divided into nominal or ordinal data. Got it? So categorical features are, can, like, if the data is nominal, then the concept that we use to deal to convert categorical data to numerical is one hot encoding. You might be thinking that, ma'am, what is the need, or what is the need of conversion? See, practically, uh, categorical data such as eyes are red, blue, green, or black. Computer doesn't understand. We have to convert that blue, green, brown, or black into numerical data to make the computer understand in the algorithm, right? So the categorical data is further divided into nominal, that is one hot encoding, and the other one is ordinal due to label encoding, right? So the two types of encoding available are one hot encoding for the nominal data. In Pandas, we use the get underscore dummies function, which is also used in machine learning. But for machine learning, I thought I should give you an idea. Scikit-learn library, we also use the one hot encoder. And for ordinal data, in Pandas library, we use the cat.codes function. And for scikit-learn, we use the label encoder function. Getting my point? Is this point getting clear to everybody? So how does it happen? For example, if we have a column of fruit and these are the categories, right? I want to convert it into categorical data. Presently, it is of object data type. What do we mean by object data type? String data type. And the moment I change is data type. That was the mistake I was doing. I was doing a .as type. I was changing one type to another. To know the type of the column, we do D type. And for type conversion, for changing one data type to another, we use the AS type category, and that's how I get the output is exactly the same. There's no difference in the output. Yes, but the data type has now changed, and it has also understood that fruit has got two categories. One is apple and the other one is orange. Clear? Is this point getting clear to everybody? Right? And then print type fruit categorical value, we get these values. Got it, learners? Categorical data is getting clear to everybody. Getting back to the practical file of this, we have performed arithmetic operations. Datetime module is now very clear. And we can also do resampling of the time series data. That is, the time series data can often come with irregular intervals, right? It's not always a day after a day. So we can also do resampling in time data, which is the process of changing the frequency of the time series data either by upsampling in frequency or downsampling, decreasing frequency. So how do we go about it? We set the index to date in place true, and then select the D types number based on the days and do the sum. So are doing on the DF. Where is the DF? This is the DF that we are talking about. So this is the DF, the change and the future date. And here we get the df resample, where we are trying to sum up all these values. Right? 10 plus 11 plus 12 plus 13, 14, 15, 16, 17. We have resampled the values and therefore we get the values as 45 and 145. Got it? This is all for the 1st of January 2023. So I can take the summary of the data. Resampling allows us to take the summary of the data. And now coming on to categorical data. There are two types of category, ordinal and nominal. So here I have created a list of categories and values. And how do I create a categorical data? By using pd.categorical values, I get this output. And how can I count the occurrences of each category? By using value underscore counts function. Right? That point is also clear. Value underscore counts function is clear to everybody. Come on, learners, respond. Is this point getting clear to everybody? And then we have creating dummy variables. Again, I have this categorical data and dummy variable will create the number of values true and false, right? And label encoding is achieved with the help of df.category as type. So there are two types of encoding happening over here. This is for nominal data and this is for ordinal data. Clear? So again, the dummy assisted practice is given for you for on the same data set. The one which I had shared it before, that is housing underscore data. Will you all be able to do this? Faculties, are the learners doing the assisted practice? I want to know the response. Any questions, any doubt in that? Please let me know. So basically, text is nothing but your string variables. What are the different operations that we can perform on string variables? Changing uppercase to lowercase, lowercase to uppercase, finding out or replacing any substring. So what are we doing in this case? Yes, learners, tell me. We are creating a data frame with these columns and what are we trying to find out? Can anybody tell me what are we trying to find out using str.len function? What is this function doing? Tell me, learners. Now we are trying to calculate the length of each string. Got it? And we are adding. Have you understood how to add a column in a data frame? Just put the name of the new updated column equal to sign and the new column with the length gets, with the output. Clear? Getting my point? Any questions, any doubt till here? What is happening with str lower function? Tell me. What is this str lower function doing? Abhijita, Aishwarya, Akshat, Pragna, converting the elements into lowercase. Yes? Are we understanding the code? Simple. How to deal with string function, which is very common in normal pandas also. In normal NumPy also, we had done that, even in data frames. Clear? What are we trying to do in this case? Here we are trying to find out the substring, that which of the data has data in it. Hello world Python. So data science is the only word or element in the row which contains the string. So that is why all else are false, only data science has true. Getting my point, learner? So it's returning me a Boolean value in terms of true and false. Got it? Yes, learners, are you there? Good, Naina, Abhijita, Pragna. Now tell me, what is iteration? Now tell me, what is iteration? Tell me quickly, what does iteration mean in any programming language? I'm waiting for you, learners. Traversing through every element, right? Why do we want to traverse through every element? So that we are able to check some condition criteria, right? That's iteration, looping basically, right? So in normal, Python, what are the different looping structures available to us? How do we iterate in normal Python? Tell me. What are the two looping structures available in Python? Tell me, what are the two looping structures? Come on, nobody understands that. What are the two looping structures available in Python? Tell me quickly. For and while. Very good. And what is the difference between for and while? Come on, I'm not asking very tough questions. Please respond. What is the difference between for and while? Nobody understands? NMIT? Come on. What is the difference between for and while loop? Nobody understands? Come on, this is very strange. I'm asking a very basic question. Ashwarya, Akshakriti, Amarthuna, Amratuna. Come on, Darshan, Dhanush, answer. For iterates to initial value to end of the value, incrementing the iterator. And can we say it's a count control loop? That's the correct way to answer. For loops are count control loops, Weber. We know the number of iterations in advance, whereas while checks the condition and then iterates, right? Then if we want to do this iteration in pandas, what is the challenge in pandas? How is it different? What is the thing that we are looking or in pandas library? Now in pandas, we are looking things as real world data set in terms of rows and column. Generally, I want to iterate through the rows of the data frame in one go, not a particular item, not one single item, but a complete row together, like in SQL. Yes or no? Here we would like to iterate a row that is all the elements in the row together, right? Or all the elements in one column together. Agreed? Right? The whole idea is that we want this processing to be fast. We don't want the system to slow down because it has to iterate. Suppose there are 10 columns in one row, then we don't want it to be, slow down. We want it to be efficient. That is where the pandas provide efficient methods for iteration and applying functions to all the elements of the data frame. So the different types of iteration available are iter rows, iter tuples, right? And iter items. Please look here. These are the three methods that can be used for iteration. That is iter rows, right? Then iter tuples, and then we can also have iter items, right? So iterating over the rows. Please look here. How are we going about this? Here we are creating this data frame. Let me first cut this and then explain you. Right here we have this data frame df.pd.data frame over here with column 1 and column 2. So what is the challenge over here? That I want to iterate all the elements of the first row and then second elements of the second row. Got my point, learners? Right? So how do we go about? If I do a df.iter rows, automatically it will give me index and rows of the column. That at the first index, this is my data. At the second index, this is my data in the form of tuple. Got my point? Now suppose if I add an existing column, suppose if I add one more column to it, right? Suppose I've added one more column. Then also it is able to give me an iterate. So even if there are 2 columns, 3 columns, or 100 columns, iter rows is capable of giving me the answers completely. Got it? Now, why is it not giving me the output? Can anybody tell me? Why is it not giving me the output? Right? Because I'm not added this. So for the row, I want to give. Got it now? So has this made iteration easier and faster, learners? Then we also have an apply function to the existing data frame. All right, so let me again cut it. So this is my existing column, and the new column I want to apply is multiplying each element with 2. Got it? By using the apply function. So arithmetic operation is done. But which one is the best operation? Vectorized operation is best. Why? Can anybody tell me? What does vectorized operation do? It does element by element calculation. Clear, learners? Are you able to see the difference? And this is how it adds it. Here we don't even need to run the for loop. What is the beauty of vectorize operation? What does vectorize operation mean? Do you remember that? Do we need to run the for loop explicitly? Do we need to run the for loop explicitly? It automatically iterates and implicitly runs the code for me. And similarly, can I do iterating over series? So if I have created the series, I can run on series.item. These PDFs and PPTs are useful in understanding the concepts. So iteration in Pandas can be achieved with the help of iter rows, apply or vectorize operation. Iter rows are most successful for smaller data sets, apply for complex row-wise transformation, and vectorize operations are the fastest and the best method at the moment. So always use vectorize method. So iter rows does not preserve the data type across the rows. Each row is converted to a series, which might lead to type changes if columns have mixed data type. Less efficient for large data frames compared to the vectorize operation. And the disadvantage of iter rows is it is not generally recommended to modify a data frame while iterating over it using the iter rows, as it can lead to unexpected behavior. Right? Syntax, we are very clear. For index gives me the index of the values, and row series in data frame. In data frame, index is the current row. Row underscore series is nothing but the data of the current row in terms of tuples containing the index and data of each row. Right? So this is how I create my data frame of year and sales. And here when I run the iter rows, I get the index along with the row, year, and sales. I get the tuple value. Right? This is what we have seen practically. Yes, learners, we've already run it and seen before. Yes. Or do you want to run this code? Type in and run this code quickly. I want everybody to type this code and do this activity quickly. Yes, learners. Vaibhav, Ragna, Pranav, quickly do this activity. Right? So try to understand one more thing, right? Why do we want to use this? Because we want the processing to be faster. The other method that we have used is df.apply function. Now, np.sum axis is equal to 0. What does axis equal to 0 mean? Tell me, from arrays we understand. What does axis equal to 0 mean? That means we are going to take the sum of all the rows. Axis equal to 0 means operation on rows. Absolutely correct, Akshat. Right, Vaibhav. So over here, we are doing np.sum, which applies to all the rows, and that is why it takes the value of sum, and output of this is 27, and the output of q is going to be 75. Clear? And if I give axis equal to 1, it means columns, operation on columns. So it will sum up all the values of the column to get the output as, for the first row 34, second as well as third row as 34. Getting my point? Clear to everybody? Got it? So we understand we also have map and apply function. I'm just trying to give the a comparison between map and apply function. Map works only on series, but apply works on series and data frame. That is why it is more preferred method. It accepts functions and it applies also. Works on multiple columns. Map does not work, but apply does. And element wise, yes. Got it? So apply function is more preferred function in Pandas. Got it? Now, what is sorting? Tell me, what is the concept of sorting? Learners, quickly. What is sorting in Pandas? Or what is sorting in general? Come on, tell me. None of you understands what is sorting? Arranging the data in ascending or descending order, right? What do we mean by ascending order? What do we mean by ascending? Come on, nobody understands even ascending. From lower to higher values, right? And what is descending? What is descending? 10 to 0, higher to lower. And if they are string values, then what does ascending mean? It means from A to Z, right, Abhijita? And if it is string, then it becomes Z to A. That point is also clear? Okay, right. So when I do df dot sort underscore values, if I want to do sorting on the columns based on employee ID, by default, what type of sorting do you see? By default, we see ascending type of sorting, right? By default, we see ascending type of sorting from lower to higher values. Only this column is sorted based on the other things. Clear? You would say, ma'am, if I want to do it in descending order, then we just have to pass this parameter. There is no thing as descending, but we will pass the parameter ascending is equal to false, right? Here we have no ascending order, but here we will have ascending is equal to false. Getting my point? Clear? If I want to do it with two columns, please look here. If I want to achieve sorting in multiple columns, how do we go about this? So it says first is skill, skill is true. That means the ones with Java, J comes before P is coming before in the order. Then capital Python has more value than the lowercase. So capital P Python is before the Python with lowercase. Got my point? Now, what is the role of this second column, employee ID equal to false? Only in the case where the values are same of the skill. Then we would, select the second column, that's employee ID, and then sort it in descending order. Got my point, learners? Have you understood this point? Abhijita, Vaibhav, Pragna, Akshat? Again, I'm repeating, please listen to me. For multiple columns, how does the sorting happens? That scale by default is in ascending order. So we understand that the capital letters have more priority than the lowercase. So this is in the lowercase. But what is the role of the second column or the second criteria where these two skill match? Then we use the employee ID, right? Then we do it in descending order because over here we passed it as false. Now clear? Karthik, Jagannath, Chetra, Balvivek, Krishna, Kiran, Faiz, Hamsika, Mahir Reddy, Anshika. What happens if I want to do the sorting based on the rows? Df dot set underscore index employee ID in place equal to true. That means what is in place to? That whatever changes are in data frame, they are also reflected. So by default, employee ID, it has just set the index with employee ID, and now I can do the sort index also. For access equal to 1, it will do it alphabetically. Age will come to pay. And otherwise, if I give access equal to 0, then it will do like 7, 12, no, 7, 10, 12, 15, and 21. Clear? Got it, learners? Now let's run it practically. Neha, Hamsika, Harshita, Malatesh, are you all there? So sorting in pandas, again, it's a data frame consisting of rows and columns. So the rows can also be sorted as well as the columns or the values can also be sorted. Both things can be possible as well as in ascending and descending the column. Both things are possible. So here I have created a data frame. Look at my data frame over here. I generally like to keep it separate because I can do the comparison of the output. That's the idea, otherwise no other. So this is my data frame. I am creating it from the dictionary. What is the advantage of creating from dictionary? That my keys will automatically become my column names, right? And now I sort values by age by default in ascending order. And if I want to do it in descending, what will I do? How will I change it to descending? I will pass the parameter ascending equal to false. Now we see it in descending order, learners, right? And if I want to change it to salary, that's also, I can do it in descending. I can also do it through name also. Clear? Any questions, any doubt till here? And if I want to do it with multiple columns, how do I see it with multiple columns? With one true and false, we will not be able to see it. If I want to do it with age and salary. Okay. So what I'll do is I'll add one more column with the same age. Okay. So maybe here 22. Salary is 2000 only. And the name is maybe Sam. Okay. So that's the changes I made in the data frame, learners. I'm just sending the data frame to you. Please make the changes in the data frame. So Sam, here a descending Charlie that gets added. But if I'm doing it for multiple criterias, now let's look at over here. Age is true. So this is the age is 22 for both. All right. And here is Alice and Charlie. Okay. But now the salary is false. So the first one with higher salary is above than 2000. Got it? Multiple criteria is getting understood. And now if I change it to name, so now Sam will come before than Bob. Is the point getting clear to everybody, learners? And if I want to sort by index, then I will just do df.sort index. Ascending is equal to false, and I can get this out. In whole of data analysis, as I've been saying, that statistics and the graphs go hand in hand. So basic use of graph is to understand the distribution of the data. When I say distribution of the data, spread of the data. And there is one more important term in whole of data science, machine learning, AI is probability. Do we understand the term probability? What is the probability of getting head when I toss a coin? Yes, learners. Who's going to answer this? What is the probability of getting head when I toss a coin? Nobody understands this? What do we happen? What are the probable output when I toss a coin? It's tail or head, right? It's tail or head. And what is the probability of getting tail? That is equal to half, right? The number of success upon the total number of outcomes. And I talk about head, that is also half. What is the probability of getting 1 when I roll a dice? What is the probability of getting 1 when I roll a dice? It is equal to 1 by 6 because the output are 1, 2, 3, 4, 5, 6. Everybody understands this point, right? So when we are dealing with data, practical data in real life, we are always talking about these two terms, the population and sample. The population here does not refer to the population of a country, city, or state. Here is the number of items or group of people which are under the observation. Population refers to the group of items under observation. And when we take a part of it, or data, that becomes my sample. So again, this is an important concept in whole of machine learning and AI, that we do not talk about the whole of the data, 100% data. Why? Because it can be huge. It can involve a lot of cost as well as time. So when we take a part of the data sample, we try to analyze through that particular sample. Getting my point, right? The point over here is the statistical data distributions, right? How my data is spread, describe how the data points are spread out across values in a data set. Understanding these distributions helps in analyzing and interpreting the data. So in most of the graphs that we are going to deal with, we are trying to understand the distributions. We need to understand the revealing patterns, trends, and the underlying structures in it, right? Now let's understand like what kind of graph are we going to draw, what kind of analysis are we going to do. So if this is my x-axis, right, we understand graph as two-dimensional structure, and this is my y-axis. Here it represents the probability because here we are talking about the probability distribution graph. All right. What is the probability of throwing one when I throw a dice? It is equal to 1 by 6. So the value is around 0.166. The probability of the 2 is also the same. 3 is also same, 4, 5, and 6. And therefore, we get this kind of distribution, which is known as uniform distribution. Have you understood this probability distribution graph? That basically we are trying to find out what is going to be the output, probable output. Getting my point? Is this point getting clear to everybody? Right? Let's understand it with another example. If I roll two dices, right? What is the probability that the sum is going to range between 2 to 12? So the total number of outcomes when I throw two dice could be 36. Agreed, learners? The minimum value of the sum is 1 comma 1 because when I throw both the dice, the sum is 1 comma 1 and the maximum is 6 comma 6, that is 12. Clear? So the probable outcomes are 1 comma 1, 1 comma 2 to 1 comma 6, right? Then we have 2 comma 1, 2 comma 2, and then we have 2 comma 6 and further outputs. Clear? Is this point getting clear to everybody? Right? So what is the probability of getting the sum 2? It is 1 by 36. What is the probability of getting 3? It is 1 by 18. So on x-axis, we have the number of events. The values can range between 2 to 12. Some can never be 0 and 1. And on the y-axis, we have the probable values. So this kind of distribution is known as a normal distribution. So how are we able to understand? The graph is explaining this. And this type of graph, can anybody tell me what is this graph known as? Anybody who understands these graphs? Is it a bar graph or is it a histogram? Yes, tell me. What do you think? This is a bar graph or a histogram? It's a bar graph. And histogram, what is a histogram? Bar graph is used for categorical data. Histogram is used for continuous data where we calculate the number of class intervals. So this is the power of visualization of graphs. We understand different types of distribution so that we have these two peaks. This is known as bimodal. Here we have this comb distribution. We have this edge peak, extra value coming out. This is how a normal distribution looks at. This is imbalance distribution, which is known as the skewed distribution. And this is nothing but your uniform distribution. Got it? Is this point getting clear to everybody? Maruti, Manya, Manvit, Nagendra, Vaibhav, Aishwarya, Ranjan, Rakshita, Shreya, please let me know. So now let's understand data visualization. That is visualizing the distributions of our variable is an important step in exploring and analyzing the data. And therefore, the first basic library that was built by John D. Hunter in 2003, that is known as Matplotlib, which helps us to draw different types of graphs such as the bar graph, histogram, scatter plot, area plot, as well as the pie plot. Clear? Right? Now to understand little technicalities of this Matplotlib library, if we look at the architecture of this Matplot library, it consists of three layers. At the lowermost layer, we have the backend layer, which consists of figure canvas layer, renderer layer, which knows how to draw on the figure canvas, as well as event layer, which can handle user input such as the keyboard, strokes, and mouse, etc. Above this layer, we have the artist layer, which is known as the primitive layer with line, rectangle, circle, and text, or the composite layer that is axis, ticks, and figures. And on the topmost layer, we have the scripting layer, also known as the pie plot. Very, very important layer because this is the layer on which we as users work, right? At the back end, the library handles all the mouse, rectangle, circle, text, etc. At the topmost layer, we are pass commands to draw the different graphs. Getting my point? And that is why we always do import matplotlib.pyplot as PLT. We do not need to load the artist layer or the backend layer. We use the scripting layer. Clear? Then we have anatomy of the matplotlib plot. That is, we have the center, the title of the graph. In a graph, main figure, we can also subgraphs, all right, with their own titles and legends. Do we understand the term legends? That refers to the key that the dark blue, data points are referring to the zero value, and the green turquoise one are referring to the one. And which is the command which helps us to create these subgraphs, more than one graph in main figure? The command that is being, or the function that is being used is the subplot, right? The different arguments of this subplot function is n rows, n columns, and index. So what do we use? We use the number of rows, number of columns, and the index. Now, what do I mean by that? How many graphs do you see in this one figure? How many graphs do you see in one figure? 6, right? Can you tell me the number of rows in this particular graph? Can you tell me the number of rows in this particular graph? Yeah. So they are total number of rows are 2 and columns is 3, right? So every subplot function of rows and 3 columns. 2 number of rows and 3 columns. 2 number of rows and 3 columns. And this refers to my first graph, the index. This refers to my second graph. This refers to my third graph, etc. Let's start with data visualization. Before that, let me give you the link for the Matplotlib. All right. So data visualization is nothing but a very, very important part of data analysis. It is a graphical representation of the data to reveal patterns, trends, insights that might not be easily apparent from the raw data. It involves creating visual elements such as charts, graphs, maps to communicate complex information. So it helps in our understanding. And we understand that Matplotlib is one of the very fundamental libraries for data visualization built by John D. Hunter, which helps us to create static, animative, and interactive visualization. Different types of graph we will practically draw over here, such as histogram, pie charts, subplots, tree chart, bubble chart, bar chart, etc. All right. So one of the very basic, graphs or chart is a line plot. Yes, learners, you remember we had discussed the line plot on the very first day, right? So how do we go about coding? Everybody has got this file. So the first step that is required to create the graph is that we need to import this matplotlib.pyplot. Why pyplot? Why do you think that Matplotlib we are only importing the pie plot? Tell me, learners, why pie plot? Tell me why pie plot? Yeah, because it's the topmost application and it is the scripting layer in which we as users work. No, we do not work on any other layer. It is this layer on which that we work. Getting my point? Got it? Right? And then importing the NumPy. Do we understand the function np.linspace? Yes, learners. Do we understand np.linspace? What does the linspace function do? If I say 1 comma 10. Do you see? It creates values 1 to 10 equal values, and by default it has created 1, 2, 3, 4, 100 values. So if I give a comma of 5, now you see what does the np.linspace function do? It will create values between 1 to 10. The first and the second is a starting point, but will equidistance value 1, 2, 3, 4, 5. So 5 values have been created. And if I give it as 10, now we see that the values between 1 to 10 all equidistance from each other. Getting my point? Everybody is able to understand this. So here we are going to create values from 0 to 10 and it will generate 100 values. And based on these 100 values, I am also getting my y value for each of the x. Clear? Is this point getting clear to everybody? And which is the function which I am going to use to create a graph? It is plt.plot. What is this function? It is plt.plot. This is x and y. Label is equal to sine wave. We will get the output. Color is blue. Line style is dash. And the color width is equal to 2. Right? These are the certain parameters that can be passed to make the graph better. X-axis, we are using the X label. Y-axis, we are using the Y label to label it, and the title. Okay. So this is the legend, and then we have the plt.show graph. Please look here how we are getting the output. Do you see this? This is the legend. This is sine wave, right? The title over here is line plot is equal to sine wave. X-axis, we have the x-axis. Y-axis, we have the y-axis. Got it? Can I change the style? Yes, I can change this to red. Then I can change it to maybe a dot and to the scatter plot. Please try to understand the significance of each graph. Why do you think we have so many graphs? Scatter, line, bar, pie. Why do you think? Who's going to answer this question? Why do you think that we have so many graphs? Tell me, learners. Why everything cannot be represented with the help of line plot? Because every graph, every data, we need to analyze the data differently. Every data is different, right? Somewhere I would like to know the distribution, somewhere I would like to know the pattern. Absolutely correct, Sivaraj. Comparing two things, we might face difficulty for better understanding, right? And absolutely correct, Vaibhav, that due to the changes in the context of the data, that is why different graphs are required. So please try to understand what is the significance of each graph. All right. So a scatter plot is used to display the relationship between two continuous variables. So scatter plot is a graph which gives relationship between two numeric values. Each point on the plot represents an observation, and the position of the point is determined by the values of the two variables. It is helpful for identifying patterns, clusters, and trends in the data. All right. Are we clear with this np.random.rand function? Whenever you have, confusions of this kind, I would always suggest you to run it separately to understand it better. So let's run it separately. So rather than 100, let's give it as 10 value. So it is creating 10 random variables, value lying between 0 to 1. Do you see this? So in this case, it will generate 100 random variables, and y is just the 2 into x. Function is not plt.plot. Now we are using the scatter function in which I'm passing my x and y variable. Color is green, marker is O, and label is equal to random data along with the x, y, and the title of the graph. Getting my point, Abhijita, Sivaraj, Vaibhav? Can I change the style of this? Yes, I can change the style marking of it. O to I can make it as D or a triangle and then change the size. Let's understand the difference between RAND and RAND N. Now, when I do a RAND N over here, RAND N stands for normally distributed data. What do we mean by normally distributed data? That it will be like looking like this peak centrally balanced data, but mean equal to 0. What does that mean? There will be few negative values and positive values. Okay, so here it was. RAND gives the values between 0 to 1. Random, here the values can be positive and negative, but the idea is to have mean equal to 0 and standard deviation equal to 1. Clear? Any questions? Any doubt? Any other question? Any other doubt, learners? Are we clear with line plot, learners? Are we clear with line plot? Are we clear with the scatter plot? Now let's move to the bar chart. What is the use of bar chart? That this is a common way to represent categorical data. Very, very important, right? And it uses the rectangular bars of length proportional to the values they represent. This chart is useful for comparing the sizes or the frequencies of different categories. So a bar chart is a common way to represent categorical data. It uses rectangular bars of length proportional to the values they represent and useful for comparing the sizes or the frequencies of different categories. Getting my point? Right? So here we have created a list of categories along with their values. which is the function which is used to create a bar chart. Plt.bar, where I pass the first parameter, the x-axis as categories, y-axis as the y values of y-axis, color is equal to orange, edge color is black, and the label is bar chart. And now are we clear? The x label gives the label for the x-axis, y label gives y label, and title gives that. Clear, learners? Are you all getting this point, learners? Yes or no? This point getting clear to everybody? Now coming on to the very important graph, which is known as the box plot. Now let's understand the box plot. Very, very important graph. All right. So a box plot looks like a box, right? And it also helps to give distribution of data. Here we are trying to compare a box plot with its probability distribution, right? The box itself gives the data between Q3 and Q1. Q1 refers to the first quartile or the 25% of the data, and Q3 refers to the third quartile, that is representing the 75% of the data. And if we look at the interquartile range, that refers to Q3 minus Q1. All right. So it is a very, very important graph because it gives the 5-number summary, that it gives me this minimum value. This whisker is the minimum value. This vertical line gives me the Q1. The center line gives me the median or the Q2 value. The third vertical line gives me Q3. And finally, we have this last whisker, which gives me the maximum value. And the values which lie beyond this, that is Q1 minus 1.5 into IQR, these small circles are known as outliers. Very, very important term in whole of machine learning and data science. Outliers are nothing but extreme values represented of the data. Clear? Is this point getting clear to everybody? Getting my point? Right? So the center point over here is like the 50% of the data, right? And anything that lies beyond this can be considered to be away from the median. And if it is lying beyond this whisker, these are known as outliers. So that isn't it giving more insight to the whole data set, that which are the data points which are lying in the center, which are away from the center, and which are extremely far away from the center point? Getting my point? Vaibhav, Naina, Aishwarya, right? And the box plot also has this notch function, right? This notch function tells us that we are 95% confidence of the median value, that the value will lie between these range. So this parameter can also be passed to the box plot function so that we can know the range of these particular values. Clear? So here we have the lower whiskers greater of the 25th percentile or the minimum value, right? And the second is This refers to your Q1 value, the first quartile. This is your median. This is your third quartile and the upper whisker, and values lying beyond this become my possible outliers, right? So what is the use of notch? It gives me that this is the confidence that the medians are lying within this value. Clear, learners? Is this point getting clear to everybody? Or any questions, any doubt? Only Sivaraj is understanding. What about others? So what is the advantage of box plot? It helps us to do comparison. If we look at A and B, the median values are lying very, very close to each other. That A and B are lying within this particular range. And if we look at C and D, the C value, the median value, is much higher than the value of the D. The C value is much higher than the value of the D. Getting my point? Clear? Are you getting this point, learners, or not? So let's get back to it practically. So a box plot is also known as the box whisker plot, which provides the graphical summary of the distribution of the data set. So box plot is a very, very important graph. I'm sure you might have not heard about this before. Anybody who's heard about this box plot before? Anybody who's heard about box plot before? So a box plot or a box whisker plot provides the graphical summary of the distribution of a data set. It displays the minimum, the first quartile, the median, the third quartile, and the maximum value. Another important feature that it is useful for, and it is generally used in almost all the analysis, is useful for identifying outliers and understanding the spread and the central tendency of the data. Clear? So again, I am using np.random normal. So again, I am generating this random data. If you ever have confusion, as I always tell you, copy the code, paste it into a new file, and then see. It creates 100 values with mean equal to 0 and standard deviation equal to 1, right? And if I change it to 10 and this to 1.5, here it is generating 10 values with mean equal to 0 and standard deviation equal to 1. Clear? So here we are trying to create 3 different types of data with all values mean 0. But standard deviation of the first one is 1, second one is 1.5, and the third one is 2. And then give the labels. And here I am giving patch underscore artist is true and notch is also equal to true. Therefore, I get this kind of graph, right? And if I change this to false, you see the notch has been removed. Learners, do you see the notch has been removed the moment I make notch is equal to false? So it gives me a warning over here that the labels parameter of the box plot has been renamed as tick underscore labels. So this is not labels anymore. It is whatever changes it suggests, one should make it. So now run it. You see this? The warning has been removed. This is false. And the patch attest is removed. The color is also removed. Can you play around with this particular graphs now, learners? Now let's understand the comparison between radar and polar chart. Practically, this graph is used a little less because it's more used for navigation and for more scientific purpose. You might have not heard about this radar and polar chart, but definitely web chart, radar chart, spider chart, it is used for comparison for multiple variables. Do you see this? This is used for comparison of multiple variables, red, gray, and orange. This is variable 1, 2, 3, 7, and 8, right? So if there are 18 variables, this graph will be, extended horizontally. But do you see, just imagine that the same, 8 variables can be drawn with the help of this radar chart. So it is again a multi-variable graph. It is used for comparisons of different variables. Getting my point? Right? So the elements of the radar chart are the axis. This refers to my axis over here. The circular refers to the grid lines or the grid points that we need to pass. Clear? These are my data points, the label axis, and this is the legend that over here the light blue is the unresolved one and the dark blue is the resolved one. Clear? Is this point getting clear to everybody? Any questions, any doubt till here? Right? These are the elements of the radar chart. And if we look at over here, another way to use radar chart, especially for navigation purposes, for launching of satellites, your airplanes, your ship navigation, this is how it is being used. Now, the center point, we have this static point. This is the grid points. How much angle are we away along with the radius? So sometimes the angle, and generally the angle is in radians. Generally, the angles, our values are passed in radians. What is radians? 2 pi. Multiplying by 2 pi is radians. Do we understand radians? So a polar chart is represented by its radius and the angle in radians. Getting my point? So a radar chart is also known as a spider chart or a star chart. The basic advantage is that it helps in analysis of multivariate data. With radar chart, however, each radial axis acts as a dimension, allowing us to plot the multivariate data. So it acts as a dimension to plot the multivariate data. A radar chart uses one continuous axis and other one needs to be categorical or a discrete axis. Getting my point? Learners, is this point getting clear to everybody? Moving ahead with polar chart. A polar chart typically plots two dimensions. One using, as I told you, the radial distance is important, the radius, and the other one is angle. use of polar chart is generally less in the normal data analysis, but they are used in scientific and mathematical context to represent the specialized data set. Polar charts are specially suited to cyclical data sets. We can use bar graph instead of radar graph as both help in compare. Yeah, it we can, but radar chart gives more comparison in more compact way for the multivariate data, right? They can be 2 and 3 datas together, right? Even this bar chart, this is a bar chart, but this is what I told Shivaraj, that this can occupy, if they are 18 variable, it will occupy more of the horizontal space, but not the radar chart. It is more compact than that. Better now, Shivaraj? Getting my point, right? So now let's see practically how you can analyze a radar chart or a polar chart. If you look at the radar chart, here we are talking about the employee evaluation. And of course, it's multiple criteria based on its technical knowledge, teamwork, punctuality, meet deadlines, and communication. The grid values range from 0 to 4, 6, 8, 10. And here we can very distinctly see that it is the technical knowledge which takes the maximum score for employee evaluation, right? Teamwork, punctuality, and meeting deadlines, as well as communication, are all at the same level, but it is the technical knowledge which scores the full marks, right? Everybody is able to understand and evaluate the radar chart? Yes or no, learners? Is this point getting clear to everybody? Right? And if we look at the polar chart, again, we have three axes: $0, $1 million, and then $2 million. And these are the quantities sold, like 1 lakh, 2 lakh, 3 lakh. These are the quantity sold. So this is the revenue. If I move from right to left, for product one, the revenue lies between 0 to $1 million, and the amount of product sold is 1 lakh. Product two lies in the center of 1 million to $2 million, that's 1.5 million, along with 3 lakh quantities sold. And products three, more than 3 lakh quantities are sold, which is above $2 million. And product four, only 2 lakh quantities are sold, which is, yeah, here it is. Clear? Understand and analyze the outputs of product one, two, and three for the polar chart. The first one is clear, the employee evaluation. The employee evaluation is very, very clear that it is the technical knowledge which scores the maximum value as compared to the other criteria. But if we look at the polar chart, product one lies between 0 to, it is lying between these two axes, and it is on this particular grid, that is 1 lakh items quantity sold. Now better, Weber? Another question, any other doubt? Right? So now let's run the radar chart and polar chart practically. The radar chart is also known as a web chart and a spider chart due to its shape and grid lines. Got it? So what is the basic use of this radar chart? Yes, learners, we need to understand that. that the radar chart is a graphical method of displaying multivariate data in the form of two-dimensional chart with three or more quantitative variables represented on axis starting from the same point, right? So here we have categories as list. Data we are generating random.randint. Randint over here is it will generate integer values between 1 to 10. So let me run this for you. It is generating only one value between this. And now if I say 5, it will generate 5 values between 1 to 10. And if I make it to 15, it will generate 15. Clear? Again, we are supposed to create a radar chart using angles. So I am creating the length space equal distance angles from 0 to 2 np.pi. np.pi because we want the angles to be in radians. The number of categories that we have 4 categories. So 4 values, no, sorry, 5 categories. So 5 values will be generated. Endpoint is equal to false. And then we concatenate the data as well as the angles. So when I draw the graph PLT dot polar, it is the two parameters that I need to pass is angles as well as the data, and the marker is equal to 0. Then theta grids, and therefore I get this particular graph of radar chart. Do you see that, learners? So the endpoint over here is false, and let me make it to true. You see this? The last point is getting joined. Again, if I make it to false, do you see this, learners? Any doubt till here? And if you remember that in the first session, we had also done the area plot. Area plot gives the cumulative sum of the values. The area plot is also known as the, anybody who remembers the other name for area plot? Anybody who remembers the other name for area plot? None of you? It is also known as the stack plot. The area plot is also known as the stack plot, which gives over continuous values. Again, I am generating my new data x, y1 is x, y2 is x squared. And rather than using the stack plot function, I'm using the fill between function. It will color the values between x1 and x2 to get the output. Do you see this? Yes, learners, are you able to see the area plot? Can I get a quick confirmation? Malatesh, Kohli, Kiran, Karthik, Gautam, Ganga. Please respond for my motivation. Am I talking to you or are you understanding? It's just, I don't keep my sessions unidirectional. Come on, respond. Neha, only Sivaraj will respond. And Abhijita. That's it. Others are not there in the lab. You're not there. You're not working. You're not there in the lab. It seems like that. You've just logged in into the session. You will not get your attendance otherwise. Are you there or not? Lakshmi Shrikar Reddy, Monica, Nagendra, Maruti, Manvit, Manya, Prajwal, Booja, Purnesh. Come on, respond, everybody. Is it that? Is it like that? Sivaraj, stack plot is used for multiple data set and area plot is used for single. Fill in between. Are you sure on that? Well, they both are same. The stack plot and the area plot are the same, Sivaraj. No, there is no difference. There is these two functions, stack plot and fill between. Got it? Got it, Sivaraj? Sivaraj, are you there? Any other question? Any other doubt? Both can be used for multiple handling of the data set. It's not that fill underscore between is used for single data set. Is it that, Sivaraj? Can I unmute you? Between can be used for single as well as multiple data set. In Google, it told that generally the same stack plots and stacked area plots are generally considered the same thing, specifically representing multiple data sets stacked vertically to show changes over time. While a generic area plot can refer to single non-stack. No, no, no. It both can be for single and multiple. Both can be for single and multiple. Got it? Got it, Shivaraj? Yeah. Coming to the polar plots, which is used for polar coordinate, useful for visualizing cyclic patterns. Here it is important to give, as I told you, the radians and the angle. So plt.polar is the name of the function. So here also we were, in the radar chart also we are using plt.polar. But here we are giving angles, data and marker over here. And here we are supposed to give the radius and the angles to it. Right? We start from 0 and then we go till here. Getting my point? Mostly used for navigation purpose. Polar plot is also clear. Radar chart, polar chart, the difference is clear. There is a slight difference between the two. Now clear to everybody? Sivaraj, Vaibhav, anybody who's facing difficulty to run the code? No? Now let's understand the tree chart. Do we understand tree data structures in computer science? Do we understand tree as data structures in computer science? So basically, we always start from the root node, right? And the root node has its different branches where we analyze the different internal nodes, where we check the condition, and then we move on to finally the leaf nodes where the tree does not branch further, right? Something like this, we start with the root node A, it branches on to two, internal nodes with value B and C, and they further branch into D and E. If that particular node is not branching further, then this is known as the leaf node. So this is known as the leaf node. This is known as the root node. And this is known as the internal nodes. Getting my point? Is this point getting clear to everybody? Right? So we have this root A node branching into B and C, and B is further divided into E and D. So it's not like a tree structure that is getting created. It's like a rectangular graph. And the more the value, the more the area of the rectangle. So E has more value than D, so the area of E will be more. Similarly, H has more value than F, so F area will be less. Getting my point? And where is it mostly used? Tree chart represents hierarchical data. The shapes are used to show a size relative to its area. The tree maps are able to show how categories are divided based on each level of the hierarchy. Getting my point? Is this point getting clear to everybody? So a tree map is used to represent the hierarchical or the tree structured data as a set of nested rectangles. It is generally represented as rectangle. Each branch of the tree is given a rectangle, which is then tiled with smaller rectangles representing sub-branches. A leaf node's rectangle has an area proportional to a specified dimension on the data. Often the leaf nodes are colored to show a separate dimension of the data, right? So this could be the chart title, the legend, and this is referring to the different types of Tennessee whiskey, straight born whiskey, corn whiskey, etc. Clear? Any questions, any doubt till here? So how do we create this tree map? First, we need to do an pip install squarify. I want everybody to run this command. Please remove this as a comment and do a pip install squarify. Please remove the comment and do a pip install squarify. So for mine, it's already satisfied. I want everybody to run it. You're not able to install it, let me know. And can you tell me the data type of this data? What is this data type with curly brackets? Can anybody tell me what is the data type of this data structure? Too much of data. What is the data type of this structure? Yes, learners, it's a dictionary. So in the dictionary, it's a dictionary within a dictionary, right, Neha, Shivaraj? So we have this root node. Under the root node, we have branch with leaf 20, leaf 230, and branch 2 with leaf 325 and leaf 415, right? So this is the item function to flatten the hierarchical data. Def flatten hierarchy. This is the node and the parent. These are the items that I am going to extend and use the flatten hierarchy function. Once this is being done, then I can use the different subplots to plot the squarify dot plot. So what is it doing? Extracting the value from the data structure and trying to create rectangles. Once the rectangles have been created, then I plot it on as a square on all the data points. Clear? So if I run this, please look at over here. This is the tree map sample hierarchy. The leaf 2 has more value than leaf 1, therefore it has more area. Leaf 3 has more value than leaf 4. Clear? To make it more better, maybe I can make this as 5. This is 35. And maybe this as 10. Now do you see the difference? Whatever value that we are passing, based on that, the rectangles are getting drawn. Right, Vaibhav, Sivaraj, Neha, Abhijita, are you all able to run it? Run the code. Any questions? Any doubt till here? And last but not the least, we have the pie chart. Pie chart is one of the favorite charts that we have been studying from our school days. It's a circular statistical graph which illustrates the data as whole and into proportions, and it can be used to visualize the distribution of categorical data components within the whole. So if this is my category A, B, C, values 30, 40, and again 30, maybe I can increase it to 130 to see the difference. Then the different function used over here is plt.py with given values. Labels is equal to labels. Auto PCT is 1.15 and the start angle is 90 degrees. So the category C is 130, which is taking the maximum of the data. Category A is just 15%. How is it giving me this answer? Because I have passed this auto PCT, parameter to the graph. And if I change it to 2, that's how it's going to show. Clear? Any questions, any doubt till here? Pie chart is clear. Please understand the code, run the code. I'm giving you time. Next minute to everybody. If you have any doubts, please ask. I'm running it in VS Code. It's giving me different tree structure. Show it to us, Vaibhav. Will you be able to show it to us? Can you share your screen? Anybody else who's getting a different output? Please share it, Vaibhav. Good, Vaibhav. Yeah, this is how it is showing for us also. This is exactly it is showing for us, Vaibhav. It is same. It is the same. The tree hierarchy, it is the same. It is the same. Remove, I'll show you ours. It's exactly the same rectangular structure. How is it different? It doesn't show the tree structure. It is showing the rectangular structure only. You see this? Isn't it the same, Vaibhav? All right. And another important feature of Matplotlib is that instead of using two-dimensional graph, we can also use it for 3D visualization. So Matplot for 3D visualization refers to the extension of Matplotlib's libraries capability to create three-dimensional graphs. Of course, when we say three-dimensional graph, it means that now we require creation of 3D axis object for visualizing the data in 3 dimension. We require the scatter plot, line plot, and surfaces. Users can generate 3D scatter plots as well as line plots and surfaces to depict the relationship. Customization and labeling. Matplotlib offers option for customizing the appearance and the labeling of the 3D plots along with the integration with Matplotlib's ecosystem. The 3D visualization features seamlessly integrate with Matplotlib's broader ecosystem, facilitating combined visualization with the other plot types. Right? All right. So we have this example of Adani ports.csv. Yes, what are the first few commands that you will run to load the data? df.head. Basically, we are reading this CSV file using pd.read underscore CSV as data frame, and the data frame shows me first 5 values. Very good. Then the next analysis can be done as df.tail. Do you remember this? df.tail. What are the other functions that can be performed? Tell me. What are the other functions that can be performed? Yeah, tail gives me the last 5. Okay, we can do df.describe. Okay, Nana, what about others? Which gives me the statistical summary of the data, which gives me more detail about this. Then I can use df.shape. This particular data set contains of 3,322 rows and 15 columns. And very good, we can run df.info. Gives me the data type of all the columns. So 100% deliverable in Adani ports, date, symbol, and series. You see the date is automatically object data type. Symbol, series are all object data type. Are you all able to run these basic functions? If you are not able to run these basic functions, then fortunately or unfortunately, you will not be able to do data analysis. So please, if you're facing difficulty, ask and load the data set and run these functions. I request everybody to run these functions and then go in for a 10 minutes break. Tail, head, describe, shape, info. All right. Now getting back to the file, right? Let's understand that. So here, I hope this is clear to everybody because this is going to be the pulse of data analysis and science that we need to load the data. Once the data is loaded, then we need to do the head and tail, describe function, and info function to understand it better, right? But for further analysis, we also transform the data. Here you see that we have one column as DF high and DF low. Please look here, learners. We have these two columns of float value of DF high and DF low, right? So high minus low over here, right? And then, so I have created now a new column, right, with df dot h minus l, that is high minus low. What is the use? That it summarizes the values of high and low with each other, right? So now now you see there are 15 columns, but now if I do the df dot info, again, now you see a new column is also created, that is H minus L. Getting my point? Right? And similarly, I can calculate a 100-day moving average and I can create a new column again in the data set as DF100 MA. So now if I run the df.info, I get this new column. What is the advantage? That I can use these new columns for creating my three-dimensional graph, which will give me more insights to the data. Rather than, separately, I create graphs for high and low. So now I can use df dot index as one of the axes, df h minus l, the transform data, as another axis to plot in three dimension, and df100 ma to plot the third dimension. Clear? So once this is being done, you see the graph. Let's try to understand the difference between a histogram and bar chart. A histogram is always used for continuous numerical values. Please try to understand. They both look the same, but they are not. It's for continuous numerical value, and this is for categorical, data. Histogram divides the data into number of class intervals, which are known as the number of bins, right? So we divide it into number of bins. Getting my point? And in a bar chart, we have, gap between the graphs. Clear? Right? Now let's understand the significance of these number of brains. Suppose they are 100 points and are divided into different intervals, that is 0 to 2, then 20, then 20 to 40, and similarly we will have from 80 to 100, right? But what is the significance of number of bins? I can also create it from 0 to 5 and 5 to 10, and similarly I can have 20 class intervals. So if the number of bins are less, you cannot get the correct shape. But as the number of bins are increasing, that is bins equal to 24 and then 43, we get a proper shape. But as the number of bins is increasing more, we are getting this as normal distribution, it becomes very difficult to analyze the data. So to get a smooth curve from histogram, that kind of graph is known as KDE. Please learn, learners. The graph, when we smooth out the histogram by increasing the number of bins to get the shape or the distribution of graph, is known as KDE, which is also known as the kernel density estimate. Clear? Is this point getting clear to everybody? So another important graph for analyzing the distribution of the data is the KDE plot, which is also known as the kernel density estimate, which is used for visualizing the probability density of a continuous variable. It depicts the probability density at different values in continuous variable. We can also plot a single graph for multiple samples, which is in more efficient data visualization. It provides smooth representations of the underlying distribution of the data set, right? So if these are my different kernels, the kernel density estimate will take the sum of the value. If there is single, there would be a dip so that we get a smooth curve. So as we started in the beginning, basically we are interested in understanding the distribution of the data, which this helps us to understand. Right? So now if you look at a histogram versus KDE, it is nothing but doing the comparison of histogram in the left and KDE on the right, constructed using same data. Each bar or graph which are closely joined represents the kernels, are red dash curves, and the kernel density estimates the blue curve. So the values which are together are joined together, and if there is a missing value, it shows a dip. Are you is the difference between histogram and bar chart clear to everybody? One is used for continuous numerical data and the other one is used for categorical. And have we understood the significance of the kernel density estimate graph, learners? Have we understood the significance of KDE? Also understood 3D plotting. It uses three axis X, Y, and Z label for 3D surface plot. And in this particular PDF, I have added the different goals, like what do you want to do, what percentage of a whole, which is the best graph you can achieve that, and description about that. So this graph gives, it's like a cheat sheet, which can help you to understand which graph is used for what kind of data. Clear? Is this point getting clear to everybody? Any questions, any doubt, learners? Can you all please respond? Can we move ahead with the next topic? Can we move ahead with the next topic, learners? All right. Thank you, Mohammed Sayed. Thank you, Naina. So now Matplotlib is a very, very fundamental library, and an advanced library has been built over Matplotlib, which is known as Seaborn. Understanding that there are a lot of different graphs used for different kind of analysis. So if we technically talk about, how the analysis can be done, let's understand some technicalities over here. Yeah, let's understand certain technicalities over here, that when we are doing data analysis, we can also divide it in the category of univariate analysis, bivariate analysis, as well as multivariate analysis. Univariate is single value analysis, bivariate is two value analysis, and multivariate. Any graph which you can put in any of these categories. Which graph is used for analyzing only one variable? Understand? Any graph that you understand for two variables that we have done in Matplotlib? Any graphs for multivariate? No? Scatter. Scatter comes under which category? Radar chart 3. Under which category? Multivariable? Very good. Very good, Vaibhav. Yes. Abhijita, what about scatter? Very good, Vaibhav. What about scatter, Abhijita? In which category it can come? Yes, it is used for bivariate analysis. Good, Vaibhav. Malatesh, Kohli, Kiran, Aishwarya, are you getting this point? Scatter plot can be used for, since it uses two numeric values, it can be used for multivariate analysis, right? So if we talk about univariate analysis, right, bivariate scatter, right? So please try to understand. Now we are understanding the analysis or insight into more depth of value. So please be careful. Univariate analysis, we are talking about numeric as well as categorical variable. And if we want to do the numerical analysis, we always talk about the histogram, the violin plot, as well as the box plot. Histogram, we understand it gives the data of the distribution of the single data. Similarly, the box plot also gives the 5-number summary of the single data. And then we have the violin plot, right, that we will understand in Seaborn. It's an advanced library over lib. And if we talk about categorical variable, we have understood about bar chart and pie chart. And this in Seaborn, we have a count plot for doing categorical data analysis. Getting my point? Is this point getting clear to everybody? Now, moving ahead to bivariate analysis for numerical data. Now, that is why are you understanding the significance of why do we have different graphs? What kind of analysis each graph gives? Yes, learners. For numeric, we have the scatter plot or the joint plot. For categorical, we have the count plot. And for numerical as well as categorical, we can use a bar graph, box plot, violin plot, or a disk plot. Getting my point, Shivaraj, Malatesh, Kohli, Shyam, and last but not the least, we will also be doing analysis of multiple variable using multivariate analysis, that is using a bar plot, pair plot, heat map, and histogram. Getting my point, learners? Clear? All right. So now let's understand how Seaborn helps in more an in-depth analysis of the data for visualizing the graph. Seaborn is a library mostly used for statistical plotting in Python. It is built on top of Matplotlib and provides beautiful default styles, color palettes to make statistical plots more attractive. So basically, if we see at this disk plot, this particular graph, if we look at, please look here, learners. This is a combination of which graph? Can anybody tell me? This is a combination of histogram plus KDE plot. We just now saw this. This plot is a combination of histogram and KDE, right, Abhijita? Vaibhav, Sham, are you all getting this point? Okay. Joint plot is by default a scatter plot which gives between two numeric values but also gives the distribution in the opposite side. It also gives the distribution on the opposite side. Clear? Then we have the hex plot over here, right? Instead of the scatter plot, we use the hex bins. But again, you can see the individual univariate distributions on the both side of the axis. So it's more beautiful. It combines different graphs to give better results. That's the beauty of the Seaborn library. Getting my point? This is my box plot. These are my box plot. Everybody understands box plot. And what do these represent? These represent my outliers, right? These represent my outliers. Getting my point? When I talk about the KDE, this is how it shows the density. The darker color shows the denser points. Again, on the opposite side, we have the distribution of each of these points. Pair plot over here is nothing, but it is showing you your multivariate analysis. In one single picture, we can do multivariate analysis. And then we have the LM plots where we are passing this linear model or straight, fitting the straight line on the different data points. Clear? Is this point getting clear to everybody? And then we have the violin plots over here. These are the violin plots. It is again a combination of box plot. We'll do it in detail, don't worry. Box plot as well as KDE. Since the shape is of a violin, it looks like a box plot. The black line in between is nothing but your box plot. Got it, learners? Is this point getting clear to everybody? All right, so Seaborn is a Python library used for statistical data visualization that is built on Matplotlib. It provides an interface for creating attractive, informative statistical graphics, which comes in built-in databases. That's the beauty. We will not load any separate data set for analysis. So a lot of homework, a lot of practice can be done. Sorry, using the Seaborn library to make creating aesthetics. It is particularly well suited for exploring complex data set with multiple variables. So if we look at over here, the different data sets over here, first, let me show it to you. Please run this code, learners. Import Seaborn as SNS and get SNS names. Please run this code. Anybody who's getting an error while running an import? So these are the different data sets which are already built into this library. Anagrams, attention, car crashes, exercises, glue, iris, taxi, tips, Titanic. Everybody is able to run it? A quick response from everybody. Yes or no? Learners, are you there with me? Or you're not able to run it, please let me know. Vaibhav, Abhijita, Sham, others. Looking for more responses. Shivaraj, Malatesh, Kohli, Malikarjun, Kiran, Karthik, Gautam, Himsika. Good came. Very good. Others, still waiting. Giving you another minute to do. Good, Naina. Good, Abhijita. Right? So let's start with this first data set. Please try to understand. We are starting with this fMRI data set over here. So what is this fMRI database? It is a repository that stores collection of functional magnetic imaging data, right? So functional magnetic resonance imaging, that is mostly, I think so, related to brain, which will predict that like what is the output, do you have cancer or not, so which are essentially brain scans. So fMRI database is a repository that stores collection of the functional magnetic resonance imaging. Why am I giving this? If you just put fMRI database, you can get all the information on the net. All these data sets are also available on Kaggle, right? So they are nothing new specific to Seaborn. Python code is an open source, so it is freely available. So which are essentially brain scans that measure changes in the blood flow to indicate brain activity, allowing researchers to study how different brain regions activate during the various tasks or stimuli. A prominent example of fMRI database is OpenFRMI, which provides publicly accessible data sets. So the different columns for this are region represents the identifier for the subject in experiment, example S1, S2. Region indicates the brain region being studied, for example, frontal and parietal. Is it the frontal part or the back part? Event describes the type of stimulus or event during the experiment. Time point refers to the time point in seconds during the experiment when the measurement was taken. And signal represents the measured brain activity signal at the given point of time. All right. So now please load this data set, run this code, learners. So now we are not using the Pandas library or any CSV or any Excel to load. These data sets are already predefined in the Seaborn library. So we will use the command sns.load underscore data set. Right, learners? Will you all be able to do that? What are the other commands that you will run? I have run head. What are the other commands that you will run? Tell me. Yes, learners, if you're not able to do this, then there is no point in sitting in this particular course and batch. If you don't know how to load the data, how to do real-time analysis, we have started with the real-time analysis of the data. Abhijita, straight away, if you want to go to describe, let's first do the tail. Anybody in this particular session, faculties, please let me know who's not able to run these 5 main functions. That is head, tail. So this is the tail. Then the other one is, as I always tell you, shape, how many rows in column. So this data set has 1065 4 rows and 5 columns. Then we have fMRI dot info. Please do it along with me, which gives me the details of all the columns. Subject is object type, others are all integer type, even event and region. So how do I judge the categorical data? And let me do df dot describe. Yeah, there are two numerical values. Yes, learners. How do I, decide on the categorical value? Please look here. fMRI event and fMRI region. So how do I go about it? fMRI event colon dot value underscore counts. So these are the values like stimulation, Q, everything. So it's a equally balanced thing. Now getting my point, Vaibhav. Here I can definitely use unique and n unique because it's categorical data. All right, Vaibhav. Please learn these basic functions. So now it gives me two unique values, right? And if I do an n unique, they are not very useful because they give only two. I prefer value underscore count because it gives category along with the frequency. Similarly, I can do it for the region. Value underscore counts. Clear? This is partial and frontal. It's equally balanced data set. Everybody is able to run the code along with me. Very, very important. Again, I'm repeating. Please look here. Now we have started with the Seaborn library and we have understood they are already predefined data sets in this particular library that can be achieved with the command sns.get underscore dataset underscore names. So these are the different data sets. I load the data set directly from the Seaborn sns.load underscore dataset. It could be any of the data set. It could be even Titanic, right? It could be tips. So you can use any data set for analysis now, right? So here we are using the fMRI data set, which is for the functional magnetic resonance imaging of the data, where we are trying to understand the event and the region of the brain. So head, tail, shape, info. And for the object data type, I want to understand there are two types of events, stimulants, stim and Q, and region is peritial and frontal. And then there is one more, which is known as the subject. Let's see that. What does it contain? So these are the different values of the subject, the different patient name, along with their values 76. Are you not listening? All right. So now let's understand another important graph of the Seaborn library, which is known as the rel plot, which is also known as a relational plot. Short form is rel plot. Data is equal to fMRI. Kind, I'm trying to draw the graph as a line plot. X-axis I am giving specifically as time point. That's the column in the data set. Y is equal to signal. Column is equal to region. Hue. Hue is another parameter which gives the different style and event. Now, suppose if I remove this, okay, and then see the graph. Please look here. Do you see? One graph it is giving me between the time point and the signal, and the another point is between time point and signal. But this is the X, this is the Y, and I have given column equal to region. So it draws me two graphs. But if I want to make the data graph more easier to understand, then let's see that it gives me the comparison between the events also, the stem and the queue event. This is the stem and this is the queue event. I can do comparison. So this is the beauty of the rel plot. Getting my point, learners? Is this point getting clear to everybody? So if we get back to the PPT, okay, if we get back to the PPT, please understand over here. The first kind of graph that we are understanding in Seaborn is after loading the data sets which are already present as the line plot. We are trying to understand this as line plot, scatter plot, and rel plot. We have understood rel plot, but we can also obtain scatter plot and line plot from it. How do we go about it? Let's understand. The rel plot function provides access to several different access level functions that show the relationship between the two variables with semantic mappings of the subset. The kind parameter selects the underlying access level function to use. First is a scatter plot, right? If I change the kind equal to scatter, by default, a scatter plot will be drawn, and line plot if I give it as kind. So what am I trying to do? Let's first analyze this. What it is saying, let me please copy this code. I'm back on the code. Paste it over here. And it says to comment this particular line. Kind is equal to line. And now if there is no, I do not give the kind. By default, it gives me the, what is it giving me? A scatter plot. Do you see this? That means the rel plot can work as a line plot as well as a scatter plot by giving what is in the kind parameter. Clear? Another important tip that I want to give over here is, yeah, set underscore theme. You can set different themes in the Seaborn library web of. You can, set it to dark grid, white grid, whatever grid you want. As you move along, we can understand. Okay. Where is it given? Are we setting any theme over here? No, not really. Yeah. When we move to that particular point, then I'll explain you. Okay. Another way to understand any function, for example, your question also, like rel plot, you can always put a question mark and then you can get all the details about that particular function. Similarly, Vaibhav, if you are having issues in sns.set underscore theme. So Python provides this introspection to understand. So context is notebook, style is dark grid, palette is deep, font is this. And if you want to change any of these parameters, you can get all the colors, the examples here itself. Getting my point? Vaibhav, Abhijita, Shivaraj, Sham, Everybody is getting this point or not? Good, Sahil. Right? So have you understood rel plot? It gives the relationship between the plots, right? And you can draw a scatter plot as well as a line plot using the same function. What does a rel plot return? A rel plot returns a facet grid. An object managing one or more subplots. Subplot is creating more than one graphs that correspond to the conditional data set with convenient methods for batch setting of access attribute. Seaborn Facet Grid is a class in Seaborn data visualization library in Python that facilitates the creation of multi-plot grids. So are you seeing the beauty of Seaborn library? That rather than specifying the subplots, it's able to give me output in terms of multi-plot grids, and it allows the visualization of the distribution of a single variable or the relationship between multiple variables across different subsets of the data sets, right? So this is how you can even get 4 plots. When I have categories such as sex, male, and the time is lunch, I can get 4 different graphs. Clear? This is the next database that we need to load. That is the tips database. So getting back to the code again, I want everybody to load this tip data set quickly. That's going to be the last part of this session. And what are the 5 main functions that you will perform to analyze the data? Yes, quickly, learners. What are the 5 main functions that you will perform? Quickly, who's going to tell me? Type in those functions quickly. What are the 5 main functions? Good, Sahana. Head, tail, info, describe, and shape. Everybody do that before leaving the session today. Everybody load the tips data set and work on head, tail, all these functions. Good, Sahana. I want everybody to do that. And if you're not able to do it, please let me know. So this data set is quite small. It contains only of 244 rows and 7 columns. So this is the different columns: total bill, tip, sex, smoker, day, time, and size. Tips dot describe. Do you see that? Everybody is able to load these, right? And then we can also create a scatter plot and then the rel plot. All these plots can be created. So I'll just show you how a rel plot, the graph that we saw, which is missing over here, how we can create it on the tips data set. I'll just show you. Yeah, you can check out the value underscore counts function also for different categorical data. This is the graph that I was talking about. Here we can create this. I'm also sharing the code. Please copy this rel plot data x total tip hues x column time and row is equal to day. Yeah, everybody is able to get this. The beauty of rel plot, the same graph that we had seen, learners. It's not day. Row is not equal to day. Row is equal to 6. And change this to day. Yeah. So male, female on different days. Got it now? And how do we deal with categorical value? Tips slash 6 dot value underscore counts. Everybody please do this before leaving the session. So there are these many males and these many females. If you look at the days over here, these are the value counts over here. It is not the days, it might be the day. Saturday, Sunday, Thursday, and Friday. Right? Then the other category over here is smoker. How many smokers do we have? Less number of smokers and more numbers of non-smokers, right? Anything else which is category? We've already done sex, smoker, day, and then let's do it for the time. Time and size also. Let's do it for time and size also. So dinner time and lunch time, people come more for dinner time. Size. How many people come? So generally very few alone and more in the size of as couples. Clear? Are we good to go, learners? Yeah. Good, Sana. Good. Everybody's able to do it? So a quick recap of today. Today we have started with the most important part of data analysis, that is data visualization. And in visualization, we started with the Matplotlib. How, the topmost layer, the scripting layer is used for designing the graphs, right? And the graph that we have understood in Matplotlib was line plot, radar chart, pie chart, tree chart, polar chart, right? These are the different graphs we covered in Matplotlib, box plot also, right? But advanced library over Matplotlib is Seaborn that we are doing presently. That Seaborn has already pre-built databases and gives more design and coloring and different insights to the data, right? So tomorrow we will again continue this journey of data visualization, try to understand different other graphs analysis on data set in the Seaborn library. And after we complete this Seaborn library, we would be moving on to certain mathematical concepts of linear algebra. So it's a long file that we need to cover tomorrow. We will, after Seaborn, we will also cover the 3D visualization, Plotly, and then move ahead with the linear algebra.
And that brings us to the end of this Applied Data Science with Python session. In this video, we explore the foundation of data science through Python, including NumPy arrays, Pandas series and DataFrames, indexing methods, data frame creation, and the importance of data visualization and analysis. We also saw how these tools help transform raw data into meaningful insights, and these could help support smarter decisions in real-world situations. The key takeaway is simple. If you understand data structures, indexing methods, and visualization basics, you already have a strong base for deeper data science work. Thank you for watching. Until next time, keep learning with Simplilearn.